Hey there. Welcome to the next stage of your learning journey. Congratulations on completing your first course. You've learned how data professionals contribute to the success of an organization and the main tools and techniques they use on the job. Now you'll learn how to use one of the most powerful tools available to data professionals, the Python programming language. Computer programming refers to the process of giving instructions to a computer to perform an action or set of actions. You can use different programming languages to write these instructions. You might choose a specific language based on the project you're working on or the problem you want to solve. The Python programming language is super useful for working with data. Data professionals use Python to analyze data in faster, more efficient, and more powerful ways because it optimizes every phase of the data workflow, from exploring, cleaning, and visualizing data to building machine learning models. This course will give you a strong foundation in Python fundamentals and prepare you for more advanced data work in your future career. If this is your first experience with the Python programming language, welcome. This course does not assume you have any prior knowledge of Python. We'll begin from the beginning and work through each concept step by step. Take it one step at a time and go at your own pace. As you develop your Python skills, you'll apply what you learn to gain valuable practice working with data. And if you have experience with Python, that's great too. I'll help you apply your knowledge in a new way and demonstrate how to use Python for data analytics specifically. Let me introduce myself. My name's Adrian. I work as a customer engineer at Google Cloud. This means that I work with our customers to understand the technologies they have at their disposal to solve data analytics needs. I first learned Python when I wanted to create an electronic journal. I got tired of buying a new physical one every year. I learned how to password protect it, and to this day, it's still one of my proudest moments of using Python. Throughout your career as a data professional, you'll have the opportunity to continually learn and grow. To me, that's one of the coolest aspects of the job. And learning Python is one of the most rewarding parts of that growth process. I'm still learning new ways to use Python all the time, both at work and for fun. Now, let's review what you will learn. We'll start with a general introduction to Python and discuss why it's such a popular programming language among data professionals. You'll learn fundamental coding concepts such as variables and data types and how they help store and organize your data. You'll also get a chance to start writing your own Python code. Next, you'll explore functions or reusable chunks of code that let you perform specific tasks. Functions help you work with data quickly and efficiently. You'll also learn about conditional statements, which tell the computer how to make decisions based on your instructions. Then, you'll discover the power of loops, which repeat a portion of code until a process is complete. You'll also learn how to work with strings, which are sequences of characters such as letters and punctuation marks. After that, you'll explore data structures in Python, which are methods of storing and organizing data in a computer. You'll review the most useful structures for data professionals, such as lists, sets, dictionaries, and data frames. Finally, you'll apply your Python skills in an end-of-course project that you can add to your professional portfolio. The end-of-course project features a unique data set based on a workplace scenario. In future job interviews, you can share your project as a demonstration of your skills and impress potential employers. Learning Python will take your data analysis skills to the next level. It'll also be a great addition to your resume. Knowing how to use Python is a key credential for data professionals and will give you a big boost as a job candidate. I'm here to help you every step of the way. And remember, you set the pace. Feel free to watch the videos as many times as you like and review topics that are new to you. By the end of this course, you'll know how to use Python to explore and analyze data. Let's get started. My name's Adrian. I work as a customer engineer at Google Cloud. This means that I work with our customers to understand the technologies they have at their disposal to solve data analytics needs. I come from a non-traditional background, started out in nursing, spent several years there before I realized that while dealing with patients and helping patients was definitely fulfilling, it wasn't exactly what I wanted to do for the rest of my life. There were a number of transferable skills that I learned from my previous career as a nurse. First being critical thinking, second problem solving, and third assessment. Within advanced data analytics, critical thinking and problem solving becomes key when trying to debug. Furthermore, when looking for answers online, you need to be able to assess what information you're being given and understand how to apply it to fix your problem. Another skill that I was able to bring over from nursing is soft skills or interpersonal skills, which are critical in advanced data analytics as you try to work with others in a collaborative space. I got into this career because I had gained skills related to programming just throughout my life. I didn't really understand how I could apply it or the fact that I could actually apply it. When I got an undergraduate degree in English and history, and it was after realizing what the job opportunities were for humanities that I had to think again about what my next step would be. And that's where technology came into play. And I found that I could actually use technology and integrate that with what I was doing from a humanities point of view with English and history and get into digital humanities. That led me to data analytics through the process of, or the concept of knowledge management. We're in a space where every company is going to become a data company. Whether you're working in medicine, whether you're working in retail, whatever it might be, data and the ability to manipulate and leverage it is going to be critical. My favorite thing about data analytics is it can be incredibly entry level. Once you understand those basics, you can get started on your own. You don't need to have a formalized university degree. You don't need to have years and years of experience. Getting started is something that can be done as long as you put in the work to get the elementary foundation down. Hi there. I can't wait to explore Python with you. During our journey together, you'll learn how to use the Python programming language to power your data analysis. This course will give you a foundation of essential Python skills that you can continue to build on throughout this program and your career. We'll begin with an overview of Python's main features and capabilities and discuss the basics of Python programming. You'll discover how Python can help you work with your data quickly and efficiently. Then, we'll consider Jupyter Notebooks, an interactive environment for coding and data work. You'll learn about the useful functionality of Jupyter Notebooks and how to write Python code in the notebook environment. Python is an object-oriented programming language based on objects that contain data and useful code. Next, you'll explore the benefits of object-oriented programming for data professionals and become familiar with its basic concepts. After that, you'll discover variables, one of the building blocks of Python programming. You'll learn how variables help you store and label your data and how to assign specific values to variables. We'll also review the conventions or widely accepted rules for naming variables. Learning these conventions will help you write code that is clear, precise, and consistent. Finally, we'll explore fundamental data types such as integers, floats, and strings. You'll learn how to convert and combine data types to organize your data. When you're ready, join me in the next video. Python is a powerful coding language that has become one of the preferred tools of data professionals worldwide, and for good reason. In this video, we'll explore what Python is and why it has become so popular. But first, let's discuss some basic elements of programming languages in general. Programming languages originated with the development of electronic computers. They were, and still are, the words and symbols that we use to write instructions for computers to follow. Communicating with a computer ultimately relies on computer hardware. A transistor is the most fundamental component of the computer because it controls the flow of electricity through a circuit. A transistor can exist in two states, on or off, like a switch. When a transistor is on, electricity passes through it. When it's off, it blocks the electricity. This duality defines how computers operate. If you chain enough transistors together, each either on or off, you can create complex logic. So how does this relate to computer programming? Well, because computers are just billions of transistors, or switches, they understand things only in binary terms. You may have encountered this concept before. Binary. Binary is represented as ones and zeros. These numbers are just an easier way to refer to the on and off sequences of transistors when a computer receives instructions from a program. Computers are powerful, but they still need to be given instructions, and they can only understand instructions that are given in binary. The engineers who first designed computers encountered this and discovered a problem. Computers are great at understanding binary, humans are not. This problem is what gave rise to the first programming languages. The very first programming languages were difficult to use, required lots of training, and often only worked on the specific machine that each was designed for. These types of languages are known as low-level languages. Over time, new coding languages developed to simplify and generalize programming instructions. The programming languages became easier to learn because they were designed with simpler rules and structures, known as syntax. Modern programming languages use syntax that's much more familiar to humans. These languages are known as high-level languages. And this brings us back to Python. Python is a high-level language that's versatile and easy to learn. Simply put, Python is friendly. In fact, some people might think that the name itself is scary, but the creator of Python didn't name it after a giant snake. He named it after a British comedy trope, Monty Python, because he wanted it to be easy and approachable. In addition to Python being versatile and easy to learn, it's also powerful. This combination of qualities has made it a favorite not only of data professionals, but of scientists and web developers too. Part of what makes it so powerful is that it's open source, and developers have created many libraries and tools to make many jobs requiring Python easier. A library is a reusable collection of code. For instance, you could hand code a function that takes two numbers, adds them together, and returns the sum. But what if now you want to add three numbers, or four? You can write a more complex function that lets you input any combination of numbers, and it will return the sum. But summing is a super common task, so you can save yourself a lot of time by just using a math library that contains a sum function. There are thousands of Python libraries that contain code for tasks as simple as summing numbers and as complex as building a neural network for an artificial intelligence application. You'll learn more about libraries soon, and you'll learn about neural nets and AI and how they fit into the world of data analytics in a later course. This certificate program focuses on advanced data analytics, so you'll learn to use Python as it's most often applied in data analysis work. You'll also learn about NumPy, Pandas, stats models, matplotlib, Seaborn, scikit-learn, and more. These are code libraries that are used every day by data professionals on the job. You'll explore these in detail later. The ease of learning, ease of use, versatility, and power of Python make it one of the most used coding languages today. Because it's so widely used, it has a large and active community of users who are willing to help and provide support, which makes it a great coding language to discover and explore. As you move through this course and the entire certificate program, always remember that coding is simple and complex. In other words, each line of code represents a small, simple idea, but together those lines of code can express very complex logic. Coding can be frustrating at times, but also a lot of fun and very rewarding. You will practice coding a lot in this course, so you can get better and better. Lastly, don't be afraid to make a mess. Experimenting is part of the process, and practicing will help you quickly improve your coding skills. Previously, you learned that Python is a high-level programming language. This means that Python uses more human-friendly syntax and more closely resembles a spoken language. In fact, Python is simple enough that you can learn some of its basic concepts just by example. In this video, I'll demonstrate some of the fundamentals of Python. I'll introduce you to some new terms, but we won't take into account formal definitions and processes. We'll consider these things in more detail later. For now, just take a moment to get familiar with the code and how it works. The first thing we'll do is print to the console. If we tell the computer to print "Hello World," it will output "Hello World" for us. In fact, the print function will output whatever we enter in its parentheses. Of course, Python is also capable of performing computations. If we divide the sum of 5 and 4 by 3, we get 3. In Python, we can also assign variables. You can think of a variable like a container that you can name. A container's contents are known as its value. For example, here we create two new variables. The first variable is called country, and we're assigning to it the value of Brazil. The second variable is called age. We'll assign it the value of 30. Now we can refer to the values Brazil and 30 by their variable names. When I give the country variable to the print function, it returns Brazil. Similarly, when I give the age variable to the print function, it returns 30. Python can also be used to evaluate statements. For example, I can check if 10 to the third is equal to 1,000. It is, so the computer returns true. Notice that so far I've used the plus sign for addition, the / for division, and 2 asterisks to indicate an exponent. Like in mathematics, these signs are known as operators. A lot of them are straightforward. However, some might not be so simple. Take this last case, for example. I used 2 equal signs to check the equivalence of 2 values. When used properly, the computer will return either true or false. What happens when I use 1 equal sign? I get a syntax error. You might have noticed from earlier examples that the single equal sign is reserved for assigning variables. Just like in spoken languages, Python has rules that govern its construction. You'll learn many of these rules in this course, but I won't discuss them in detail now. You won't easily learn a new spoken language by studying a big book of its rules. You're more likely to learn it by speaking it, hearing it, reading it, and writing it. It's also a lot more fun that way. It's the same with Python. So for now, don't worry about memorizing any rules. First, let's observe Python in action. As you might expect, if I make a false equivalency, like 10 times 3 equals 40, the computer will return false. I can even use a variable I defined previously, age, in a new statement. 10 times 3 does equal age. You'll recall we assigned age a value of 30, so the computer returns true. Python also lets me perform actions based on conditional logic. Here, I tell the computer that if the value of my age variable is greater than or equal to 18, then it should print the word adult. Otherwise, it should print the word minor. The value stored in the age variable was 30, so the computer returns adult. Another common task in Python is looping. Looping performs the same action to each element of something. Here's a simple loop. For each number in this list of 1 through 5, we print the number. The computer outputs 1, 2, 3, 4, 5. Here's another example. This time, I'll create a list containing the numbers 3, 6, and 9, and assign it to a variable named myList. Now I'll loop over my list, and for each number in the list, the computer will print that number divided by 3. And there you have it. It outputs 1, 2, and 3. Now, let's return to the conditional statement we wrote. If age is greater than or equal to 18, print adult, otherwise print minor. What if we want to repeat the same action for many different age values? We can write a function. A function is a chunk of code that can be reused to perform the same task. We'll define this function and call it isAdult, and it will accept an argument called age. By the way, an argument is information that you give a function in its parentheses. Now, in the body of the function, we'll use the same code we use for the conditional statement. Nothing happens when we run this code, but check out what happens when we call the function and give it an argument of 14. The computer returns the word minor. Now we can perform the same evaluation as many times as we want, simply by using the isAdult function we just created. And remember how I told you that libraries are part of what make Python such a useful and powerful language? Python has its own library of built-in functions that perform common tasks. For example, here's a list of numbers. 20, 25, 10, and 5. We'll assign this list to a variable named newList. We can use the built-in Python function called sorted and enter newList as its argument. It returns our list with its values sorted from least to greatest. These are just a few simple examples of what Python can do. These simple processes can be stacked and layered and combined to create algorithms and programs that could possibly change the world. Python's power is bounded only by the limits of your imagination. Now that we've explored what Python is and what it can do, I'm excited for you to learn more about it. Recently, you've been investigating the power of Python. There are many environments programmers use when exploring all of Python's capabilities, and one of the most popular is Jupyter Notebook. You've already encountered Jupyter Notebook. The examples that I presented to you previously were done in one. We'll use this platform to write code and perform analysis throughout the course. We'll also provide you with information about how to set up Jupyter Notebook on your own computer. But that's optional and not necessary to complete the Advanced Data Analytics program. Jupyter Notebook is an open source web application for creating and sharing documents containing live code, mathematical formulas, visualizations, and text. Using a Jupyter Notebook lets you collaborate on data projects and integrate code. Plus, it puts all of your output in one document, which is very useful, especially when first learning about programming. To illustrate why, take this example. In the computing world, most code is written in an environment similar to this. This is a terminal-based text editor. Notice that it's like a single page that's infinitely long. If I perform an operation or write a line of code, it executes immediately when I move to the next line, and I can only move forward. I can't return to an earlier line of code, insert my cursor there, and change or run it. A terminal-based text editor is a very useful environment for many situations, but it's not always the best or easiest to work with for data analytics projects. Now, compare that to our notebook environment from before. Here, I can more easily modularize my code into cells to organize them in sections. Cells are the modular code input-output fields into which Jupyter Notebooks are partitioned. I can move code around, add it, and delete it with the click of a mouse or the press of a button. And it's great for visualizations and presentations. I can add comments, annotations, and explanations using Markdown syntax. Markdown lets you write formatted text in a coding environment or plain text editor. For example, I can add titles and bullets, tables, and mathematical formulas. These are just a few of the many features of Jupyter Notebooks that make it a preferred platform among data professionals. As you move through this course, you'll create projects in Jupyter Notebooks to showcase your skills as a data professional. You're well on your way now. In this video, you'll learn more about Python and what makes it both approachable and powerful as a coding language. You're going to learn about object-oriented programming. Specifically, we're going to discuss classes, methods, and attributes. What follows is a brief introduction to object-oriented programming. A more detailed discussion is beyond the scope of this course. You'll have the opportunity to further explore object-oriented programming in your future career as a data professional. Object-oriented programming is the programming system that is based around objects, which contain both data and useful code that manipulates that data. An object is an instance of a class. Think of it like a fundamental building block of Python. Lists, functions, strings, these are all objects. The main idea behind object-oriented programming is to have both data and the methods that manipulate it within objects, allowing for more organized, accessible, and reusable code. The most important concept in object-oriented programming is the class. A class is an object's data type that bundles data and functionality together. In other words, the reason why it's useful for an object to have a type or belong to a class is because it allows us to build a bunch of useful tools that can be packed directly into the object itself. This will make a lot more sense with an example. When we put the words hocus pocus inside quotations and assign that to a variable called magic, this variable becomes an instance of the string class. Because it belongs to the string class, it behaves in a certain way and has a lot of built-in functionality reserved for strings. We can swap the case of the characters by typing magic.swapCase with empty parentheses after it. We can replace some characters with new characters by typing magic.replace and entering the characters we want to replace and what we want to replace them with. And we can split the string into a list of two strings using .split and an empty pair of parentheses. These actions are known as methods. A method is a function that belongs to a class and typically performs an action or operation. They use parentheses. In our examples, each method acted on the value of our variable. It changed it in some way. That's what I mean when I say that methods typically perform an action or operation. By the way, you don't have to memorize these methods. There aren't many people who know all of them. Most coding environments have ways to access a list of methods available to a given class. In Jupyter Notebook, we type a dot and then hit the tab key. Notice that we're attaching the method to its class instance using a dot. That is called dot notation, and it's how we access the methods and attributes that belong to an instance of a class. There are many different classes in Python. You've encountered some of these already. The core classes of Python are integers, floats, strings, booleans, lists, dictionaries, tuples, sets, frozen sets, functions, ranges, and none, which is a data type that returns an empty value. There are also many additional custom-defined classes that come with libraries and packages, and you can even make your own. Okay, the last thing we're going to discuss is attributes. Attributes are values associated with an object or class which are referenced by name using dot notation. They don't use parentheses. Attributes are especially important for custom-built classes and more complex data structures like data frames. You'll learn more about these later, but here's an example. Suppose we have a data frame called planets that contains a row for each planet and columns that represent planet name, its radius, and the number of moons it has. One attribute of this data frame would be its shape. This data frame is 8 rows by 3 columns. Another attribute of the data frame class is columns. Calling this attribute on the data frame object returns an index object containing the column names of the data frame. Attributes allow you to access characteristics of a class, but they don't do anything to it or change it. Perhaps you're beginning to appreciate how object-oriented programming is an ideal structure for data analysis. By packaging data together with ways to manipulate it and learn about it, objects are the fundamental building blocks of Python and part of what makes it such a powerful tool for data professionals.
My name is Hamza, and I'm an applied machine learning engineer. I love building models, I love building large-scale systems, and that is exactly what I do at work. It's a form of art for me that you get to create something from scratch that does not exist, and you put it into production, and it is used by about 100 million users. The scope of my work is to build, maintain, and productionalize large-scale models. So Python is pretty much the central theme of my job. Python is a programming language which helps you manipulate data, which helps you build models, and you can use it to create production-level models and softwares. There are a lot of other programming languages which will do the same things that you're looking for. For me personally, I use Python because there's a lot of documentation, there's a lot of help, and there is a lot of learning from past failures from different programming languages, which has been incorporated to help Python be user-friendly and be used by everyone around and easy to adapt. You never get hired as a good chef because you have good knives. You get hired as a good chef because you have good cooking skills. This is the same thing. Python has helped me become a better data scientist, a better machine learning engineer, and it has helped me understand diverse set of mathematical applications in machine learning, which previously I was not aware of. I think the unique strength about Python is that it's just a multifaceted tool. It's not just one thing. It's not just for data manipulation or data cleaning. You can do transformations, data cleaning. You can build models. You can put them into production. You can make an API out of it. You can build monitoring systems on top of that. Those are the strengths of Python that makes you a sort of master of all in when it comes to data science. The one most important thing that when you do an online course or you're studying anything is that learning is not linear. There's a very steep curve, and then eventually you just get to the aha moment. The thing is that in the first 2 weeks when you're doing a certain course, you might be like, okay, this is not making sense and it's not working for me and it's not doing what I'm looking for. So just stick to it and be consistent. The learning curve is always steep in these things, but then you eventually get to a point where you say that, oh, I know all of these things and I can put all the knowledge that I have together to build something great.
In this video, we're going to focus on variables. Variables give meaning to code. Think about nouns in language. Nouns are used to identify people, places, or things in a sentence. Variables in Python are like nouns. Variables point to values. They're not the values themselves. If you have the expression x equals 3, x is the variable and its stored value is 3. The 3 exists in a specific location in the computer's memory. The x points to that location. Another way to think of a variable is like it's a container with a label on it. A container is a separate thing from whatever it contains. But if I ask you to pass me the ketchup, you'll know which bottle to pass me, even if you can't see the ketchup inside it, because the bottle is labeled. Variables can store values of any data type. A data type is an attribute that describes a piece of data based on its values, its programming language, or the operations it can perform. In Python, this includes strings, integers, floats, lists, dictionaries, and more. You've already encountered some of these in this course. We'll explore these data types throughout the program. When assigning a new variable, it's helpful to answer these questions before you code. What's the variable's name? What's the variable's type? And what's the variable's starting value? These questions help you create variable names that remain meaningful and easy to reference again later. Naming variables is important because these names are reminders for yourself and others about what you are storing in the variable. Calling the data type also helps you understand what the data can and can't do. Next, consider how you will assign expressions, which can help make your code more concise. An assignment describes the process of storing a value inside a variable. And an expression is a combination of numbers, symbols, or other variables that produce a result when evaluated. Now, let's examine that in Python. We'll translate a variable algorithm into Python code. Let's start with a list of the ages of the starting 5 players on a professional basketball team. We'll assign the list to a variable called ageList. Notice that we didn't call it, for example, x, because x doesn't tell us anything about the value it contains. And if we encountered an x later, we might not remember that it's a list of ages. One nice thing about Python is that the computer interprets the data type for us automatically when we assign a new variable. This is called dynamic typing. Dynamic typing means variables can point to objects of any data type. Also, there are no default types for most new variables. So we need to assign or initialize before calling them. Let's return to our example. We'll find the maximum age of the basketball players by using Python's built-in max function and passing our age list to it as an argument. We'll assign the result to a new variable called maxAge. When we call the variable, the computer returns a value of 34. This is an integer. So the maxAge variable contains a value whose data type is integer. Now, suppose we want the maxAge variable to contain a string value. We can convert it to string by using the string function, represented by str, and reassigning the result back to the maxAge variable. Now, our variable has a data type of string, which is indicated by the quotation marks in the output. You'll learn more about strings later. For now, just remember that those quotation marks are unique to strings. We can also overwrite the contents of the variable entirely if we want. For instance, we can store in it the text string 99. Now, when we call the variable, the computer returns our new string. There are a couple of important things to note here. First, notice that when we converted maxAge from an integer to a string, we reassigned it back to itself. If we hadn't done this, and we had simply used the string function on the max age variable, the computer would have returned a string, but the contents of the variable would not have changed. Generally, when you want to modify the contents of a variable, you have to reassign it. The second important thing to be aware of is that the order that you run your cells in matters. For example, if I rerun the cell where I first assign the max age variable and then call this variable in a new cell, you'll notice that its value has reverted back to the integer 34. It's no longer the string 99. In these examples, the value contained in the max age variable changed every time we reassigned it. That's why it's dynamic. Variables are convenient because you can refer to them instead of the values they contain. So if we define a new variable that contains the minimum age in our list of ages, we can subtract the two variables to find the age difference of the oldest and the youngest player. There is so much we can do with variables and expressions in Python. The program asks a question, and the variable helps us capture the answer based on input from a specific source. Just remember that if you want to modify the contents of a variable, you usually need to reassign it. It's also important to consider that the order you run the cells in matters when coding in Jupyter Notebook. Soon, we'll learn about variable naming conventions and restrictions. I'll meet you there. Python has certain spelling or grammatical rules to follow, just like any other language. In programming, we call these rules naming conventions and naming restrictions. If you completed the Google Data Analytics certificate, you might remember that naming conventions are consistent guidelines that describe the content, creation date, and version of a file in its name. Naming restrictions are rules built into the syntax of the language itself that must be followed. In Python, there are some important naming conventions to keep in mind. One of these is to avoid keywords. A keyword is a special word that is reserved for a specific purpose and that can only be used for that purpose. You've already encountered some keywords, such as for, in, if, and else. There are others too, which you'll learn about soon. Keywords should never be used when naming variables. Thankfully, you don't have to worry about accidentally using a keyword. First of all, keywords will appear in a special color in most coding environments. So a good rule to follow is that if you're naming a variable and the name changes color, don't use that name. And if you're thinking, but I like colorful variable names, and you try to assign a value to a keyword anyway, the computer will say, not so fast, and throw an error. Python will let you make spelling mistakes, but it won't let you use a keyword for a variable name. By the way, throw an error is a common phrase that every coder knows only too well. It just means that the computer returns an error and your code doesn't successfully run. Also, some names are reserved for existing functions, for example, print and str. So you should also avoid using names of existing functions. To sum up, a big thing to keep in mind regarding variable naming conventions is that you don't want to use reserved keywords or functions. Precision is essential when programming. This is why there are naming restrictions for variables. For instance, variables can only include letters, numbers, and underscores. This means you can't use spaces, tabs, or special characters, such as the $sign or ampersand. Another rule to keep in mind is that while variable names can contain numbers, they must start with a letter or underscore. Also, Python is case sensitive, which means capitalization matters. Lastly, variable names cannot include parentheses. This is because parentheses have other uses in Python. Let's review some examples of effective and ineffective variable names. Any underscore a underscore variable is a valid variable name. Any underscore a underscore variable underscore 2 is also good. However, 1 underscore is underscore a underscore number would be invalid because variable names must start with a letter or underscore. Apples underscore ampersand underscore oranges is also invalid because it uses the special character ampersand. You do have some flexibility when naming your variables, since these are references you create. These conventions and restrictions just help make them consistent and useful. Okay, now let's go back to parentheses to understand more about how these function in Python. When doing calculations, the rules for parentheses follow the mathematical order of operations. For instance, if we input 2 times 3 plus 4 in parentheses, Python will read 3 plus 4 first because it's following the order of operations. This is equal to 14. But 2 times 3 in parentheses plus 4 equals 10. That's because the operation within parentheses will always be completed first. By the way, if we don't use any parentheses, Python will follow the standard mathematical order of operations. Naming conventions and restrictions for variables help maintain consistency and usefulness as you continue to use Python for a variety of activities. A key part of working with Python as a data analytics professional is being able to effectively name your variables to create meaningful code. Soon, we'll explore conversions and data types. Bye for now. Previously, you learned about variables and how to name them. You learned that variables point to values that are stored in the computer's memory. In other words, the variables are like containers, and the values they store are their contents. Now, you're going to learn more about the values that your variables can contain. As you've learned, text written between quotes in Python is called a string. Programs need to manipulate data, which can come in a lot of different forms or types. These data types include strings, integers, and floats. First, a string is a sequence of characters and punctuation that contains textual information. Strings are instantiated with single or double quotation marks or the string function. This is an immutable data type, which means the values can never be altered or updated. An integer is a data type used to represent whole numbers without fractions. And float data types represent numbers that contain decimals. Most computers understand when you tell them to add 2 integers or add 2 strings. But generally speaking, computers don't know how to work with different data types. If you try to mix different data types, it can sometimes throw an error. As always, the computer tells us the cause of the error. It's like a little clue to help you improve your programming skills. Read the errors carefully, understand what they're trying to tell you, and use that knowledge to fix the mistake. In this example, the last line of the error message says we've encountered something called a type error. 7 is being read as an integer, and 8 is being read as a string because of the quotation marks. No wonder we got an error. You can't add 7 to a word. As a data professional, you'll often need to aggregate a lot of data of different types. This will require converting the various types so they can be combined successfully. There's an effective method for doing this, but first, it's important to know what you're working with. Python offers a helpful way to identify data types with the type function. You can use the type function to have the computer tell you the data type. For instance, the type function here tells us that A belongs to the str class, which is short for string. The number 2 belongs to the int class, or integer, and 2.5 belongs to the float class. As a reminder, a class is an object's data type. The class bundles data and functionality together. Now, let's find out how to combine these different data types. There are 2 ways to convert data in Python. First is implicit conversion. Implicit conversion automatically converts one data type to another without user involvement. Here's an example. In arithmetic operations involving both integers and floats, the interpreter works in the background and converts integers to floats. You don't have to specify anything in your code to do this. However, if you want to convert numerical values to strings, you will need to do an explicit conversion. Explicit conversion is where users convert the data type of an object to a required data type. We use the predefined functions int, float, and str. This is sometimes called typecasting because the user casts or changes the data type. Let's use the str function inside the string we want to have interpreted as output. And now the output of this calculation will be stored as a string. Great work. You'll continue exploring data types and seeking solutions to errors throughout this program. Debugging or figuring out what's wrong when your code won't work is a really useful skill for any data professional. Also, as a final tip, all of us in the profession, even experienced data professionals and code developers, search for answers online when we encounter an error. This is a common strategy and a huge time saver. Always look to the data community for answers and inspiration. We've come to the end of the first section of the Python course. You've developed a lot of new Python skills already. Well done. Along the way, you've discovered that Python is a powerful tool for data professionals and learned how Python can help you work with your data quickly and efficiently. We began with a general introduction to the Python programming language and explored how data professionals use Python to power their data analysis. Then, we discussed Jupyter Notebooks. You learned about the main features of Jupyter Notebooks and how to write Python code in the notebook environment. Next, you explored the benefits of object-oriented programming for data professionals and learned about its basic concepts. After that, we focused on working with variables. You learned how to assign specific values to variables and effectively store and label your data. We also reviewed the standard naming conventions for variables. You learned useful guidelines for making your code clear, precise, and consistent. Finally, we explored different data types in Python, such as integers, floats, and strings. You learned how to convert and combine data types to organize your data. Coming up, you have a graded assessment. To prepare, review the reading that lists all the new terms you've learned, and feel free to revisit videos, readings, and other resources that cover key concepts. Congratulations on your progress so far, and I'll meet you again soon. Welcome back. I'm excited to continue our learning journey together. I really enjoyed exploring the basics of Python programming with you. You learned that Python is a powerful tool for data professionals and lets you analyze data with speed, accuracy, and efficiency. You now know how to use variables and data types to store and organize your data, and have already started writing your own Python code. In this course, we'll continue to build on your foundation of Python knowledge. By the end of the course, you'll be able to write statements in Python code to perform multi-step operations on your data. You'll also learn how to write clean, readable code that can be easily understood and reused by other data professionals. Being able to collaborate with teammates is one of the most important skills for a data professional. And writing clean code is a great way to collaborate with your teammates and help your team achieve its goals. Working with clean code helps your team work faster, communicate more effectively, and produce better results. We'll start with functions, or reusable chunks of code that let you perform specific tasks. Functions are like the verbs or action words of a programming language. You can call on a function at any time to help you perform useful actions on your data, such as sorting, classifying, summarizing, and much more. Then, we'll discuss how to write clean code that can be easily understood by your teammates and collaborators. You'll learn about two important elements of writing clean code: reusability and modularity. Both of these practices speed up project development and help data professionals focus on core business needs and avoid spending time doing rework. After that, we'll examine another key aspect of writing clean code: commenting. Commenting is a useful practice because it helps you consider your thought process while documenting your workflow for teammates. Using comments to describe the component parts of a problem helps you solve it in clear, simple steps. Next, we'll discuss how to use operators to compare values. We'll review two types of operators: comparators and logical operators. Comparators, such as greater than or less than, allow you to compare two values. Logical operators, such as and or, let you connect multiple statements together and perform more complex comparisons. Data professionals use operators to analyze and make decisions about their data. Lastly, we'll consider conditional statements, which tell the computer how to make decisions based on your instructions. You'll learn how to write if-else and else-if statements. Data professionals use conditional statements to structure complex operations and to perform all kinds of practical tasks, such as binning data and organizing files. Conditional statements make your Python code more flexible and powerful. When you're ready, I'll meet you in the next video.
Hi, my name's Latifa. I'm a customer engineer here at Google Cloud. My specialty is data analytics. Essentially, I'm taking what a customer already has on another cloud provider or in their data centers and figuring out how to translate that onto our cloud platform. When I was a kid, I had two dream jobs. One was to be a secretary and the other one was to be a waitress. I did both of those things. I enjoyed them immensely. One of the biggest lessons I took away from my time waitressing is to just face the issue head on. I was a very timid person when I started waitressing, and so if something was wrong with somebody's order, I would just hide in the kitchen until they could make a new one and then pretend everything was fine the whole time. That didn't always go my way. As you can imagine, it actually would just make people madder. And so from that, I took away just learning to admit your mistakes, facing it head on, and not being afraid to talk it through with somebody. Well, learning Python was a little difficult. A lot of the first issues I had was with setting up Python and the environment and picking IDEs. I don't know if you've ever played a video game, but you can spend so much time on that initial screen just character selecting. Or there's so much time you can just get bogged down picking these small, minute things before you get to the meat and potatoes. The way I overcame those challenges was one, committing to just starting. I realized it's really powerful to just say you're gonna spend X amount of time doing this, and even if you made no progress, you can at least go home or go to bed that night saying I did what I could, and if that wasn't enough, it just wasn't enough. I really took the time to understand how to read Stack Overflow, right? I was super frustrated with it when I first started coding, but that was because I just wanted to copy paste the code into the console and just magically have it work for me. Or, I was trying to blame everything on the version of Python I was running or the package version I was running, and that just wasn't the case. So just learning to slow down and actually understand what it's saying and how this translates to the error I'm running into or the issue I'm running into versus just trying to brute force my way almost to the next topic or the next question was really helpful. On my first team, which was a purely sales team, we were tasked with creating these business intelligence reports for 2,300 different customers or potential customers. I think my manager at the time calculated it out, and we would have all had to put in 50 hours a week for the next 3 weeks to complete that task. That's not ideal, right? Nobody wants to spend 8 to 10 hours a day making intelligence reports. But with my coding knowledge, I was able to automate the creation of those business reports and create the 2,300 within an hour and a half. And it just felt good to know I was capable of it. The number one tip I can give people looking to start coding, you are going to watch a ton of videos, hear a ton of information. Somebody's going to talk to you about optimization, how to write the best code. But until you've actually done it, you just won't understand all the rigmarole involved in coding and debugging, which brings me to my other tip. I would say learn to debug. And then if I could give a third tip, it would be to learn to just deal with the noise. If you can start compartmentalizing into this is what I absolutely have to know to get started and to move forward, and these would be nice to knows, you'll really accelerate your learning journey.
Recently, we've been exploring variables, expressions, and data types. In this video, we'll consider another important component of programming in Python, functions. A function is a body of reusable code for performing specific processes or tasks. We've come across a few built-in Python functions so far. For instance, the print function writes text on the screen. The type function tells us the data type contained within a variable. And the str function converts an object into a string. Note that in previous versions of Python, print was handled as a statement and did not use parentheses. But for Python 3, the print syntax is a function and requires parentheses, even when there are no arguments used and the parentheses are empty. Okay, so we know that Python has many built-in functions. But if we want to tell a computer to do other things, particular to our own use cases, it's important to know how to define our own functions. To define a function, we use the keyword def at the start of the function block. You've encountered the define function once before in a previous video, but let's consider another example. When defining a new function, always begin with the def keyword. The name of the function comes next. Let's call it greeting. After that, we have the function arguments, also known as parameters. A function's arguments are always written in parentheses. The arguments are the things you give to the function to modify in some way. You can call them anything you want. Whatever we call them here when we define the function is how we'll have to refer to them below in the function's body. In this example, our function will have just one parameter, name. When we're done defining the arguments, close the parentheses, put a colon at the end, and hit enter to get to a new line. Now we can write the body of the function. This is where we say what we want the function to actually do. Note how the body is automatically indented to the right. In Python, lines of code are hierarchical. Any line that is indented pertains specifically to the less indented code that precedes it. We can add as many lines as we'd like to the body of the function, but each line must be indented to the right. Here, it's indented 4 spaces. You can use however many spaces you like as long as you're consistent. However, 4 spaces is usually the preferred way because it makes code more readable. Our greeting function will take a name and output a greeting using that name. We'll have the function print welcome, the person's name, and then on a new line, print you are part of the team. To finish defining the function, simply unindent the next line of code. Now we can call the function using the word greeting. Inside the parentheses, we'll type the name Rebecca. Then we'll run the cell. Of course, functions can do a lot more than print messages. This is just one simple example of defining your own function. Next, let's consider how to get values out of a function. This is where return values can be used. Return is a reserved keyword in Python that makes a function do work to produce new results. But instead of printing the results, the function saves them for later use. Let's define a new function that accepts 2 arguments, the base and height of a triangle, and returns the area of the triangle. The area is calculated as base times height divided by 2. We use the keyword return to tell Python that this is the value that we want to come out of the function. Instead of printing, return lets us store this value in a variable. So, suppose we have 2 triangles and want to add the sum of both areas. Here's what we would do. First, calculate the 2 areas separately, storing each value in its own named variable. Then, add the 2 areas together, assigning the results to a variable called total area. If we call this variable, the Jupyter Notebook returns its value, but we don't have to call it. We could continue writing code if we want. This demonstrates the power of the return statement. It enables us to combine function calls with other operations, which makes the code reusable. Reusability involves defining code once and using it many times without having to rewrite it. There's more information on reusability soon, but for now, just understand that reusing something takes a lot less time and effort than recreating it every time. Let's do one more. Here's a function called getSeconds. This function takes hours, minutes, and seconds as inputs and returns the total number of seconds those inputs represent. In the first line, we begin with the keyword def and name the function getSeconds. In the parentheses, we give it 3 parameters, hours, minutes, and seconds. The next line performs a computation that calculates the total number of seconds and assigns that value to a variable called total seconds. The third and final line is the return statement that returns the value of total seconds. When we call the function, we have to give it 3 arguments, hours, minutes, and seconds. We'll use 16 hours, 45 minutes, and 20 seconds. And there's our result, 60,320 seconds. Now you understand more about functions and how to use the return keyword to save the results of a function for later output. Code reuse is a key element of Python that you will continue to appreciate as a data analytics professional. Your data toolbox is growing and growing, and there's more on the way. In the early years of software development, it was common for developers to write each bit of code themselves. Now we know it's much more efficient to reuse code that others have written and put in online code repositories. Or we can develop modular code, which you'll learn about in this video. Both of these practices speed up development and help data professionals focus on using code logic to meet business needs instead of doing rework. As we've discussed, reusability involves defining code once and using it many times without having to rewrite it. Consider this example. This script uses the length function, which returns the length of an object. In this case, it's the number of characters in the string. Then, it uses that length to calculate a number, which we're calling the lucky number. Finally, it prints a message with the name and the number. Each time we want to perform the calculation, we change the values of the variables and write the formula. Notice how there are exactly 2 lines that are the same in the first and second part of the code. When you find code duplication in your scripts, it's a good idea to check if you can clean things up by using a function. Let's rewrite this code creating a function to group all the duplicated code into just one line. This updated script gives us the exact same results as the original one, but it's cleaner and easier to understand. Best of all, it's now reusable. We can execute the code inside the lucky number function as many times as we need to by just calling it with a different name. Because of its modular nature, Python is well suited to making code reusable. Modularity is the ability to write code in separate components that work together and that can be reused for other programs. Modularity is closely related to reusability because it lets you reuse blocks and sections of code. Reusing code blocks can help you more effectively collaborate with data engineers on larger projects so that they don't have to start their code from the beginning. Here's an example. These variable names don't really tell us anything about what this code is trying to do. We can run it, and yes, it does something, but it was pretty difficult to read and understand that code. So, let's try to make this code clear for other users. Refactoring is the process of restructuring code while maintaining its original functionality. This is a part of creating self-documenting code. Self-documenting code is code written in a way that is readable and makes its purpose clear. This involves everything from selecting your variable names to writing clear, concise expressions. Comments are a helpful supplemental explanation of the code. When your computer registers the hashtag character in front of the comment line, it knows to ignore everything that comes after that character on that line. So, let's refactor this code to make it self-documenting. Now, the intent and construction of our code is more clear. It's also broken up into functions and commented sections. Commenting is a useful practice because it helps you think about your process while documenting your workflow for other collaborators. Although messy code doesn't necessarily cause a script to fail, the cleaner the code, the more useful it is for the rest of your team. Your colleagues will appreciate clean code because they can understand and reuse it to save themselves both time and effort. Plus, code reuse and modularity reduces errors, enhances teamwork, and builds trust. Previously, you learned about writing clean code. In that video, I mentioned that lines of code that begin with a hashtag don't get executed, and instead serve as comments for the human reading the code. In this video, you'll learn more about commenting and why it's such an important part of writing good code. Building good coding habits will enable you to use Python effectively when using data to inform solutions to business problems. Let's begin with algorithms, which will help you learn to think like a programmer and translate instructions into Python code. In programming languages, an algorithm is a set of instructions for solving a problem or accomplishing a task. One everyday example of an algorithm is a recipe consisting of specific instructions for baking bread. First, you preheat the oven to 425 degrees Fahrenheit. Then, you mix 2 cups of flour, 3 eggs, 2 cups of water, and a teaspoon of yeast in a bowl using an electric hand mixer. Then, you let the dough rise for an hour. After that, you transfer the dough from the bowl to the baking pan. Finally, you insert the baking pan in the oven. In a similar way, every computerized device is given instructions in the form of algorithms as hardware, or software-based routines to perform its functions. That's why it's important to know how to explain things logically to the computer. This is what it means to think algorithmically. You've already started to think this way because you've learned about functions, and functions are algorithms. As your coding skills develop, you'll be able to write longer and more complex functions. The best way to approach writing a new function is to break it into small, simple pieces, beginning with the comments. Outlining the comments in steps before you even write the code helps you to better understand the problem. Let's review an example. Suppose we have a square fountain, and we want to plant grass in a border around that square. Let's write a function to calculate the amount of grass seed we'll need if we know the length of the side of the fountain and the width of the grass border. As always, begin with the def keyword. We'll name the function seed calculator. Its parameters will be the two things we know, the fountain side length and the width of the grass border. Now we'll write the body of the function, breaking it into small steps that we'll outline with comments. First, we'll find the area of the fountain. Next, we'll calculate the total area of the square and the grass border combined. From these, we can derive the area of just the grass border by subtracting one from the other. Then, we'll calculate the amount of seed we'll need, which is 35 grams per square meter. We'll have to convert that to kilograms because that's what we said the function would output. And finally, we have the return statement. So let's review what we've done. We use comments to create a logical scaffolding before writing any code in the body of this function. In other words, we use comments to break down the thought process that outlines each segment of code that we'll need in order to meet our goal. The only thing left for us to do is fill it in with code step by step. We can get the total area by finding the length of one side of the larger outer square and squaring it. The length of the large square is equal to the width of the border times 2, plus the length of the side of the fountain. So we'll code that as total area equals fountain side plus 2 times the grass width. And we'll take that whole expression and square it. The area of the grass border is equal to the total area minus the fountain area. Then, the amount of seed we'll need is the grass area times 35 grams per square meter. Next, we convert grams per square meter to kilograms per square meter by dividing by 1,000 and return our seed variable. We're almost done. There's another important part of writing functions that are user-friendly and easy to understand. It's called a document string, or docstring, as it's most commonly referred to. The docstring is a string at the beginning of a function's body that summarizes the function's behavior and explains its arguments and return values. A function's docstring begins and ends with 3 quotation marks. They can be single quotes or double quotes. First, we write what the function does. It takes the form of a command and ends in a period, like calculate the number of kilograms of grass seed needed for a border around a square fountain. Next, we'll describe the function's parameters. Ours has 2. We have fountain side, which is numerical data that represents the length of one side of the fountain in meters. Then we have grass width, which is also numerical data, and it represents the width of the grass border in meters. Lastly, we'll describe what the function returns. This function returns the seed variable, which is a float that indicates the amount of grass seed needed for the border in kilograms. Great. We have a function that performs a complex task and can be used as many times as we need. Using comments to break up the parts of the problem allowed us to solve it in clear, simple steps. Best of all, other people can use this code and understand exactly what it's doing, because we've written a docstring and concise comments. So how much seed do we need if our fountain is a square that's 12 meters long on a side and we want a 2-meter border of grass around it? 3.92 kilograms. To recap, comments act as a scaffolding that breaks up your code into manageable pieces. Along with the function's docstring, they help you and others understand and use your code. It's important for data professionals to get in the habit of writing well-documented code. It's a little more work up front, but you'll thank yourself later, and so will your colleagues. You've learned about data types like integer, string, and float. Another data type is Boolean data. This is data that has only two possible values, usually true or false. The word Boolean comes from George Boole, a 19th century English mathematician. Every time you compare things in Python, the result is Boolean type data. Data professionals use Boolean data every day to control logical flows in their code. In previous lessons, you discovered how Python can be used like a calculator for basic arithmetic. Now we'll find out how to use the power of Python to compare values with comparators and operators. Comparators are operators that compare two values and produce Boolean values. All right, now let's consider an example. If we print 10 is greater than 1, a comparator produces the result, a Boolean value, true. There are 6 comparators in Python. They let us confirm whether something is greater than or equal to, less than or equal to, or not equal to something else. Data professionals take the results of comparator expressions and use them to make decisions about data assigned to these descriptions. Here's an example. Cat is not, in fact, equal to dog. So it produces the Boolean value false. Now, let's pair an exclamation mark and an equal sign, which is the not equals comparator. So the comparator checks that 1 isn't equal to 2 and produces the Boolean value of true. As we've learned, the plus operator doesn't work between integers and strings. So let's consider what will happen if we try to compare an integer and a string. Yep, another type error. The good news is that Python also has a set of logical operators. Logical operators are operators that connect multiple statements together and perform more complex comparisons. Examples of these are the words and, or, and not. These operators allow you to connect multiple statements together and perform more complex comparisons. The and operator needs both expressions to be true to return a true result. Here we're comparing strings. When used on strings of text, comparators evaluate the first letter of each string, with A being least and Z being greatest. If two strings have the same first letter, the second letter will be compared. In this case, the Y in yellow is greater than the C in cyan, but the B in brown doesn't come after the M in magenta. So this means that the first statement is true, but the second one isn't true. So if only part of an expression is true, the result of the whole and statement is false. Or statements are the opposite. If we use the or operator, the expression will be true if either of the expressions are true, and false only when both expressions are false. Try it out. Print this code. Open parentheses, 25. The greater than comparator, 50. The or operator, 1. The not equal comparator, 2. Close parentheses. 25 is definitely not greater than 50, but 1 is not equal to 2. So in the end, the whole expression is true. Now, the not operator inverts the value of the expression that follows it. If it's true, it becomes false. If it's false, it becomes true. Because there is a not statement in front of 42 equals the string answer, the result is true. Comparators and logical operators are very useful in the data field because they make it possible to write much more complex code. Later, I'll be back to demonstrate some examples of these expressions. Keep practicing and reviewing comparators and operators. I'll be with you again soon. Now that we know about variables, expressions, functions, data types, comparators, and logical operators, we can perform exciting actions in our scripts based on their values using branching, which is exactly what we'll learn about in this video. Branching describes the ability of a program to alter its execution sequence. This is a key component to writing useful scripts. Branching uses if statements based on certain conditions. If is a reserved keyword that sets up a condition in Python. If statements, also known as conditional statements, are just like using the word if in everyday life. For example, if it's before noon, you'll greet someone by saying good morning rather than good afternoon or good evening. If it's raining outside, you might choose to carry an umbrella. And if it's snowing, you'll probably wear a jacket. Here's an example of this concept in a business context. At a company, new employees can choose their usernames. However, the usernames need to fit a given set of guidelines. Maybe a valid username requires at least 8 characters. As the data professional at this business, you're tasked with writing a program that will tell the user if their choices are valid or not. To accomplish this task, we'll write a function. The goal is to define the function so that it generates a username hint using an if statement. As a reminder, the built-in len function will return the length of an object, and that can be paired with the less than comparator to identify usernames that don't meet the criteria. Great. Now your function checks whether the length of the username is less than 8. If it is, the function prints a message saying that the username is invalid. Let's review our if statement. We write the keyword if, followed by the condition that we want to check for, followed by a colon. After that, we have the body of the if block, which is indented further to the right. Here's a very important point. The body of the if block will only execute when the condition evaluates to true. Otherwise, it does not execute. What this means is, if you run an if block and the argument conditions are not met, the indented code beneath it gets ignored. The if statement is a useful construct in Python syntax. But what if we could extend it to make it even more powerful? What if we want the computer to do something else? Else is a reserved keyword that executes when preceding conditions evaluate as false. The else statement lets us set a piece of code to run only when the condition of the if statement is false. Here's an everyday example. If you're hungry, you eat. But if you're not hungry, if that concept is false, then you'll do something else. Maybe you'll make another choice and take a nap. Think about our company username example. Maybe now we want to print a message when a username is valid. The function can now go in different directions depending on the length of the username. If the username is not long enough, a message indicates that it's invalid. But if the function verifies that the username is long enough, it will print a message saying that it's valid, which is dictated by the else statement. Notice the structure of the function right now. The if statement is indented in the body of the function, and the action we want to happen, if that statement is true, is indented beneath it. We could write as many lines as we want here, and as long as they're all indented beneath the if statement, they'll all execute when that if statement is true. Then we have the else statement. Note that it's unindented to the same level as the if statement. An if statement and its corresponding else statement are always written at the same level. Beneath the else statement, we indent once more to indicate that this is what must execute when the if statement is not true. Sometimes you don't need to add an else statement because that logic is already built into the code. Let's explore a new operator that will help with this. We're going to use a new operator, the modulo. Represented by the percentage sign, the modulo is an operator that returns the remainder when one number is divided by another. The division between integers yields 2 results, which are both integers, the quotient and the remainder. So, for an integer division between 5 and 2, the quotient is 2 and the remainder is 1. For an integer division between 11 and 3, the quotient is 3 and the remainder is 2. Even numbers are all multiples of 2, which means the remainder of the integer division between an even number and 2 is always going to be 0. So the modulo division of 10 by 2 is 0. Let's review an example. This function checks whether a number is even by dividing it by 2 and checking that the remainder is 0 using the modulo operator. If the remainder is 0, the function will return true. Now here's the interesting part. You can put an else statement here. That would work, but it's not strictly necessary because of the way if statements work. Remember, when the if statement evaluates to true, the code indented beneath it will execute. But when the if statement evaluates to false, nothing indented beneath it will execute. The code will then continue running until it gets to the end of the function. Let's try entering the odd number 19 using the isEven function we defined. The function returned false because 19 modulo 2 does not evaluate to true. So the code indented beneath the if statement doesn't execute, and then the function continues running. In this case, the only remaining code in the function is return false. So that's what it does. It returns false. At first, you might prefer to include the else statement in such instances, and that's okay. It's important to know that both ways are correct. But keep in mind this technique can only be used when returning a value inside the if statement. To recap, an if statement branches the execution based on a specific condition being true, and the else statement sets a piece of code to run only when the condition of the if statement is false. For situations where there are more conditions to consider, the elif statement, short for else if, is useful. The elif keyword is a reserved keyword that executes subsequent conditions when the previous conditions are not true. It's Python's way of saying if the previous conditions were not true, then try this condition. Let's consider an example to better understand elif. It is likely the case that the weather might influence what you choose to do with your afternoon. If the weather is nice, you might go to the park. If it's raining, you might go to the movies instead. Depending on which of these activities you choose to do, you also need to decide how to get there. And the activity may determine your mode of transportation. So, the choices you make depend on different conditions at each point. These are if, else if statements you may encounter in daily life. Let's return to the username validation example. Perhaps now we want to limit how long the username can be. Maybe our business has a rule that usernames longer than 15 characters aren't allowed. Let's type our first condition. Usernames of less than 8 characters are invalid. Now we want to add another condition to this, limiting the username to a maximum of 15 characters. Notice there are two else statements. The first else is the second course of action if the first condition is not met and the length of the username is greater than or equal to 8. In other words, if the first if statement is false, then the code executes the first else statement. This else statement has two more nested conditions, if and an else. The indentations make the relationships between the different branching statements easier to read, but the nesting adds some complexity. Remember, you can choose to use as many or as few spaces as you want for the indentation, but generally it's best to use 4 spaces for readability, and it's important to be consistent. To avoid unnecessary nesting and to make the code clearer, Python's elif keyword lets us handle more than 2 comparison cases. In fact, the elif keyword allows us to handle an unlimited number of comparison cases. The elif statement is similar to the if statement. The abbreviation for else if prevents a lot of nested if and else statements. If all the above conditions are false, then the final else statement executes. Now, let's run our function on a really long username. This script works just the same as the one with nested if-else comparison I just demonstrated, but it's much easier to understand. Let's examine it. The function first checks whether the username is less than 8 characters long. If that's the case, it prints a message. Next, if the username has at least 8 characters, the function then checks if it's longer than 15 characters and prints a message if that's true. If neither of the above conditions are met, the function prints a message indicating that the username is valid. Now you know how to use if, elif, and else statements inside functions. This kind of branching is super helpful when determining the flow of your scripts. Use branching to pick between different pieces of code to execute, making your script pretty flexible and efficient. Branching also helps with all kinds of practical things, such as bin data based on its value, backup files, or to only allow login access to a server during a certain time of day. Anytime your program needs to make a decision, you can specify its behavior with a branching statement. Now you have a strong foundation to build branches in code, which is going to enable you to do a lot of useful work in Python as a data professional. You've learned so much already, and I hope you're enjoying the discovery as much as I am. You've come to the end of the second section of the Python course. You've added a lot of new Python skills to your skill set and gained valuable practice working with data. Well done. Along the way, we've explored how Python code can help you quickly perform complex operations on your data. You've also learned how to write clean, readable code that can be easily understood and reused by other data professionals. This is an important part of collaborating with teammates on any data project. Writing clean code will help your team reduce errors, work faster, communicate more effectively, and deliver better results. We began by exploring functions or reusable chunks of code that let you perform specific tasks. Next, we discussed two important elements of writing clean code: reusability and modularity. We also discussed another best practice for writing clean code: commenting. After that, we reviewed two types of Python operators: comparators and logical operators. And finally, you learned how to write conditional statements such as if, else, and else if statements. Coming up, you have a graded assessment. To prepare, review the reading that lists all the new terms you've learned, and feel free to revisit videos, readings, and other resources that cover key concepts. Congratulations on your progress. Let's keep it going. Welcome back. Wow, you've learned a lot of new Python skills. You can use variables to store and label your data, and convert and combine different data types, such as integers and floats. You can call functions to perform useful actions on your data and use operators to compare values. You also know how to write clean code that can be easily understood and reused by other data professionals. Finally, you can write conditional statements to tell the computer how to make decisions based on your instructions. Your knowledge of fundamental coding concepts is the first stage of a journey that leads to more advanced methods of data analysis. And this learning journey will continue throughout your future career as a data professional. To me, that's one of the most exciting parts of the job. I'm always learning new ways to use Python for data analysis, whether from teammates at work or from the super supportive online community. Learning new Python skills helps me become a more effective data professional. In this section of the course, you'll learn how to use Python code to automate repetitive tasks. Often, data professionals need programs to perform an action repeatedly. For example, if you're analyzing sales data, you may want to perform the same calculation on hundreds of price values. Rather than write new code each time you want to make the calculation, you can instead write an iterative statement or loop. Loops automatically repeat a portion of code until a process is complete. We'll discuss two types of loops: while loops and for loops. Using Python to automate repetitive tasks saves me tons of time and effort and reduces the risk of human error. It also reduces my overall workload and increases my productivity. I have more free time to focus on the main goal of any data analysis project: to generate insights for stakeholders. You can iterate over many different data types in Python, such as strings, lists, sets, and dictionaries. In this section of the course, we'll focus on strings. Later on, we'll discuss the other data types in detail. As a data professional, you'll often work with strings when analyzing data. For example, you might examine textual data related to a company's products, services, customer feedback, and more. Operations like indexing and slicing allow you to select, filter, and edit data quickly and efficiently. These are valuable Python skills for any data professional. When you're ready to learn more, I'll meet you in the next video.
My name is Michelle, and I'm a data engineer here at Google. I actually started as a documentation specialist right out of college, but being surrounded by so many technical people working within analytics really made me interested in the field and made me want to join the team and work in that world. I anticipated that I would face judgment or people looking down on the fact that I didn't have a degree in analytics when I was breaking into the field, and I am happy to report from my experience that did not happen. It was only my own negative self-talk in my head. Everyone around me was welcoming and accepting and really happy to have someone who took a non-traditional path into engineering and analytics on the team because of the unique viewpoints that I brought. Imposter syndrome is a very real thing. I think everybody experiences it, and so did I. There were so many times where I would stop and think, maybe I'm not meant to be here. I don't have an advanced degree in analytics or information science. Is there really anything that I could even contribute being in this room right here, right now? And the way I got through it was realizing that having a career in data analytics and data science is not about memorizing every possible answer for every possible scenario. That's not it at all. The purpose is you're supposed to develop the skills to be able to approach a problem in an analytical mindset. There was a project earlier in my career where I really wanted to automate part of an analytics workflow. And I knew what I needed to do, but I didn't know exactly how to do it. The way I approached this problem was to first write down what I wanted to do in plain English without any computer code, any programming, nothing like that. Then I had to do a lot of searching on Google. I was looking on various forums for how to do XYZ in Python, how to use a for loop, how to use Python for data science and automate analytics. And I slowly made my way over to completely automating the workflow that I wanted to automate, one piece at a time. Being able to automate that workflow has left me with a sense of accomplishment that has remained with me to this day. Sometimes it can seem really discouraging when you have a mountain of work in front of you or somewhere that you want to get to and you're thinking, this is going to be impossible, but it's really not. If you just break things down into smaller, more manageable chunks, you absolutely will get there. And then you'll get to a point where you look back and think, oh my gosh, I did it. I've made it all the way here.
If you had to do the same thing over and over and over again, well, you might get a bit loopy. And you'd probably think to yourself, I wish I could spend my time on something more meaningful. Well, that's where computers can help. They do the looping for you. As a refresher, a loop is a block of code used to carry out iterations. An iteration is the repeated execution of a set of statements where one iteration is the single execution of a block of code. And an iterable is an object that's looped or iterated over. Typically, data professionals use for loops and while loops to work with iterables. In this video, we'll focus on while loops. A while loop is a loop that instructs your computer to continuously execute your code based on the value of a condition. Magali and Fido are here to help me explain. Notice that Fido is eating treats while the treat bag is in Magali's lap. Fido stays until Magali puts the treat bag away. Then Fido leaves. This is a while statement in action. While Magali has the treats, Fido is there. Once the condition of Magali holding the treat bag is no longer met, Fido exits. After all, there are no more treats. While loops work in a similar way to branching if statements, the difference is that in while loops, the body of the block can be executed multiple times instead of just once. This is great for avoiding redundancy in code. Let's review an example. Assign the value of 0 to the variable x. As you've learned, we call this action initializing to give an initial value to a variable. Next, start the while loop. Set a condition for this loop that x needs to be less than 5. The prior line just initialized it, so this condition is currently true. Then, end the while loop line with a colon. On the next two lines, you may notice a block that's indented to the right. This is the while loop's body. There are two lines in the body of the loop. In the first line, print a message followed by the current value of x. In the second line, increment the value of x by adding 1 to its current value and assigning it back to x. In the body of the while loop, we told the computer to print the results of each iteration. Notice how each iteration changed the value of x. Our while loop started at x equals 0, then printed the message, and increments the value of x to 1. But because this is a loop, the computer doesn't just continue executing with the next line in the script. Instead, it loops back around to reevaluate the condition for the while loop. This is the second iteration. And because 1 here is still less than 5, it executes the body of the loop again. The third iteration increments x by 1. Now the value of x is 2. The computer will keep doing this until the condition isn't true anymore. Let's add a print statement outside the body of the while loop to let us know the final value of x. When the loop finishes, the next line of code is executed. So now that x has reached the value 5, the loop statement ends. The computer prints the last line of output as x equals 5. We can also use the logical operators and, or, and not that we worked with earlier. Similar to if statements, using these operators allows us to combine the values of several expressions to get the result we want. The most important thing to remember is that the condition used by the while loop needs to evaluate to true or false. It doesn't matter if this is done by using comparison operators or calling additional functions. I think you're ready for an example that uses several different concepts that you've learned so far, and even a couple that you haven't. To help you explore the example, I'll guide you as we go, and I'll explain the concepts to you. You'll probably find that as you continue on your journey learning Python, you'll encounter new concepts that can be understood in context. It's the same way with spoken language. If I say the elephant was so gargantuan that it crushed the car by stepping on it, the word gargantuan may or may not be in your vocabulary. But the context helps us understand that it has something to do with being big or heavy. It's the same with coding. Pause the video and try to figure out what this code is doing. When you're ready, continue and I'll lead you through it. In this example, we're going to write a short program that generates a random number and then gives the user 5 chances to guess it. We begin by importing a package called random. This package has many uses, but the one we want is its ability to generate a random number. Now, instantiate a variable called number and use the random int function from the random package to assign it a value. The value is a random number between 1 and 25 inclusive. Next, we instantiate another variable called number of guesses and assign it a value of 0. This variable is important because it will behave as a counter that controls the logic of our program. Now comes our while loop. We write while the number of guesses is less than 5, and below it, we give the instructions for what should happen at each iteration of the loop. First, the script will print a message telling the user to guess a number from 1 to 25. Then, we instantiate a new variable called guess, which will capture a string of whatever the user inputs. The input function used here will create a prompt that allows the user to type their guess. The next line converts the guess to an integer. This is important because without it, the input function would capture the number as a string, and it would be impossible to win the game because even if they guess the right number, the string of the number will never evaluate as being equal to the integer of the number. Now, we increase the number of guesses variable by 1. This is an important step because, remember, the while loop will continue to iterate for as long as the number of guesses variable is less than 5. If we left this out, The loop would never stop running and the user would have infinite guesses until they got it right. By the way, this syntax is a helpful shortcut. Instead of writing number of guesses equals number of guesses plus 1, we can simply write number of guesses plus equals 1. They mean the same thing, but one is way shorter. Now we're going to have our branching logic that determines what the program does. We want the behavior to be different depending on how many guesses the user has made and whether their guess was correct or not. This code is still within the body of the while loop, so it will execute on every iteration. The first line checks if the guess is correct. If it is, the while loop breaks. This word break is a key word that lets you escape a loop without triggering any else statement that follows it in the loop. In this case, if the user guesses the correct number, the while loop would break and the code would continue at the if statement below. Because the guess is correct, we print a message telling the user that they're correct and include how many tries it took them in the message. But let's go back up to the while loop and go through what happens if the guess is not correct. We use the elif statement to check if the guess was their fifth guess. If it was, we break the while loop. Evaluation would continue below, and because the guess was incorrect, it would trigger the very last else statement that outputs a message telling the user they were unsuccessful and revealing the correct number. Without this elif statement, the code would still work, kinda. The user would get a message saying, nope, try again, and then immediately get another message telling them they were unsuccessful and revealing the number. But if the guess was not their fifth guess, the code would proceed to the else statement, which prints, nope, try again. Let's run the program and try to guess the number. Congratulations! You just integrated a bunch of concepts into a single script of code and worked on a problem that incorporated some complex logic. These skills are invaluable to data professionals. Have you ever tried to withdraw money from your bank's ATM, but keyed in your password incorrectly? As you probably experienced, you only have a certain number of tries before the system will lock you out. Sure, it's frustrating if you're just typing too quickly or temporarily forget your PIN, but it's a great safeguard that helps protect your bank accounts. Well, the software in many cash machines runs using a for loop. This detects how many attempts have been made on a single transaction before blocking the user. And in this video, we're going to learn how that works. A for loop iterates over a sequence of values. A simple example of a for loop is to iterate over a sequence of numbers. For x in range 5, print x. Notice how the structure of a for loop is similar to the syntax of a typical Python statement. The first line indicates the distinguishing keyword, in this case, for. And like functions and other expressions that start a distinct code block, it ends with a colon. The body of the for loop is indented to the right. What's different in this case is that we have the keyword in. Also, between the keywords for and in, we have the name of a variable, x. This variable will take each of the values in the sequence the loop iterates through. In this example, x takes the values 0, 1, 2, 3, and 4. We don't have to use x. We could use any term we want. N, number, monkey, it doesn't matter, as long as we maintain consistency between what we name it here and how we refer to it below. Okay, now let's examine the range function. The range function is a Python function that returns a sequence of numbers starting from 0, increments by 1 by default, and stops before the given number. It can be used in while or for loops. In Python and many other programming languages, a range of numbers will start with the value 0 by default. The list of numbers generated will be one less than the given value. Check it out. By default, our range function starts with 0. After the first iteration, the value will be 1. The second iteration outputs 2, and so forth. Whatever code we put in the body of the loop will be executed on each of the values, one value at a time. You can also use a for loop to read in a file and iterate over the file line by line. The withOpen statement uses the file path to read in the file. In this case, it's a text file containing the Zen of Python, a famous poem written by software engineer Tim Peters in 1999. For easier notation, assign it the value of f. Otherwise, we'd have to write the file path again. In the next line, start the for loop for each line. Inside, you indent, and on the next line, tell the computer to print each line. After the loop is complete, tell the computer to print "I'm done." I once had to locate all of the unique words in a 2D array of text. I used a for loop inside of another for loop. The outer loop ran over each column, and the inner loop iterated over each cell for the column. That's just one example. Let's check in on Magali and Fido for another. Magali doesn't want Fido to eat too many treats, so she only gives him 5 treats per day. Fido wags his tail each time he gets a treat. Once he has all 5, he stops wagging his tail. Good dog, Fido. Data professionals use for loops in Python and other programming languages all the time. They're one of the fundamental tools of coding. They're great for performing a repeated procedure on an object with a fixed length to create something new. Next, we'll explore more ways to use loops. Earlier, you learned about the range function and how it generates a sequence of numbers starting with 0. However, your work as a data professional won't always need to start with 0. Instead, you might want to use a step parameter in the range function. This makes it possible to specify which elements of a variable or data set we want to start and end with. In this video, you'll learn how to use the 3 parameters of the range function: start value, stop value, and step value. Here's a for loop that calculates a factorial of 9. Let's explore how it works. We begin by assigning a variable called product with the number 1. Next, we have a range function that starts at 1 and stops at 10. Since the stop value is not included in the calculation, this means the code multiplies the variable by every whole number in the sequence, beginning with 1 and ending with 9. So, for n in range 1 to 10, we multiply our product variable by 1 and reassign the result back to itself. Then, we multiply the product variable by 2 and reassign the result back to itself, then by 3, all the way up to 9. This produces a factorial of 9. The factorial of 9 equals 362,880. Note that we started with 1 and not with 0. If we multiplied by 0, the product would be 0. The range function also lets us specify a third parameter to change the size of each step in our range. In other words, instead of going 1 by 1, you can have a larger difference between each of the values in your range. Let's explore an example. First, define a function that converts a temperature value from Fahrenheit to Celsius. Use the standard conversion formula. The temperature in Fahrenheit that needs to be converted is identified by x.
32 is subtracted from x times 5 divided by 9.
Next, we have a for loop that will print a table of temperature conversions every 10 degrees from 0 to 100 degrees Fahrenheit. Notice that the for loop starts at 0 and goes up to 100 in steps of 10. Remember that the range excludes the final value in a sequence. So to include 100 in our sequence, we put the n value as 101. The body of the for loop prints the value in Fahrenheit and the value in Celsius to create a conversion table. For every 10 degrees Fahrenheit, the code prints the corresponding value in Celsius on each line. So now you know more about setting parameters for the range function when you're working with for loops. As a quick reminder, use for loops when there's a sequence of elements that you want to iterate over. For example, to loop over a variable, such as a record in a data set, it's always better to use for loops. This also improves readability of your code. Use while loops when you want to repeat an action until a Boolean condition changes, without having to write the same code repeatedly. Remember, Booleans are a data type that represents one of two possible states, usually true or false. And if whatever you're trying to do can be done with either a for loop or a while loop, just use whatever you prefer. I happen to love them both, and I'm really glad I have both tools in my Python toolbox. We've covered a lot of material so far. You learned about functions and conditional statements and loops. Now we'll learn more about different data types in Python, beginning with strings. Recall that a string is a sequence of characters and punctuation that contains textual information. This is an immutable data type, which means the values can never be altered or updated. Even though strings are immutable, we can still do a lot with them. For instance, we can concatenate them. To concatenate means to link or join together. So concatenating strings is making a single longer string from two or more shorter ones. To concatenate strings in Python, we simply use the addition operator. If we have two strings, hello and world, we can join them by adding them together. The result is a single string, but it's also a single word. This is because blank spaces, or white spaces, as they're known in computer programming, count as their own characters. If you want a white space between your concatenated strings, one of the strings must contain a white space. Or you must add a third string between them that contains just a white space. The same rules apply when using variables that point to strings. If hello is assigned to greeting 1 and world is assigned to greeting 2, we can concatenate the strings by adding the two variables. We can also multiply strings using the multiplication operator. Danger times 3 equals danger, danger, danger. However, we cannot divide or subtract strings, and trying to do so will throw an error. As you know, some characters are reserved for specific purposes when working with strings. For example, quotation marks are used to indicate the beginning and end of strings. But what if we want our string to contain quotation marks? There are two ways we can approach this. The first way takes advantage of the fact that strings can be written with either single quotes or double quotes. If you want to include double quotation marks in your string, use single quotation marks to begin and end your string, and vice versa. The second way is to use the backslash, which functions as an escape character. An escape character changes the typical behavior of the characters that follow it. In this case, the typical behavior of quotation marks is to begin or end the string. But if we precede each with a backslash, they'll behave as regular punctuation marks in the string. The backslash character is useful as an escape character for other special characters in strings, too. For example, \n is a special character combination that's used to indicate a new line when printing a string. But if you want to include \n as characters in your string when you print it, you must precede the combination with an initial backslash. Moving on, we can also iterate over strings with loops. In this example, we use a for loop to iterate over each letter of the word Python and print the letter plus the letters UT. These are just a few of the ways to work with strings. As a data professional, you'll often work with strings when analyzing data. Coming up, we'll cover more useful operations that we can perform over strings. Recently, you learned the basics of strings. In this video, you'll add to your knowledge by exploring a new way to work with strings, slicing. But before you learn about slicing, you'll need some background information about how Python works. As a reminder, an object is iterable if you can sequence through all of its values or items. Indexing is Python's way of letting us refer to individual items within an iterable by their relative position. Indexing is a very important part of Python because it allows us to select, filter, edit, and manipulate data, and it opens up many possibilities to the data professional. By the way, indexing isn't just for strings. It also works on many other data types, like lists, tuples, and others, as long as they're iterable. You'll learn about these other data types soon. Python uses zero-based indexing. That means that the first element of a sequence is indexed as 0. With strings, indexing works by interpreting a string as a sequence of characters, where each character has a numbered slot. If you're reading from left to right, the first character is located at slot 0. The second character is located at slot 1, and the third at slot 2, and so on. Indexing lets us slice strings to create smaller strings or substrings. Here's an example that many data professionals have experience with. A column in a dataset contains employee salary information. In the same field, there will be both strings and integers, the currency symbol and the salary amount. In this case, Python would automatically interpret the mix of data types as a string data type. This is often a problem because we usually want values that represent money to behave like numbers so we can perform mathematical operations on them. If they're strings, we can't do that. So, to fix the problem, slicing helps us remove the non-numeric characters, like the $, from the string. In this case, we could drop the character at the 0 index of each value in the salary column. This gives us salary information without the currency prefix. Let's explore some ways of working with indices. One useful tool is the index method. Index is a string method that outputs the index number of a character in a string. Remember, a method is a function that applies to a variable. We can call it by following the variable with a dot. We use the index method to identify the location of a character or substring in a string. Here, we have a variable called pets, which has been assigned the string cats and dogs. We use the index method by attaching it to the pets variable with a dot. In its parentheses, we enter the character we want the index of. Let's find S. When we run the cell, the computer returns the number 3. This means that index 3 of our string contains the letter S. What if there's more than one of the same character or substring? Here, we know that there are 2 S's in cats and dogs, but only one index returns to us, 3. That's because the index method just returns the first position that matches. And if you search for a substring that is not there, say Z, you'll get a value error because the substring is not found. Additionally, we can also use an index number to find a specific character in that position. For example, we'll assign the string Jolene to a variable called name. By placing the index number in brackets after the variable, we can access the character at that position. Name at index 0 is J, and name at index 5 is E. What happens if we put 6 instead? We'd get an index error, indicating that the string index is out of range. You can access the last character of a string even when you don't know how long the string is by using negative indices. Let's consider an example. We don't know the length of this string, but it doesn't matter. Since it isn't super efficient to count each character out, we can reference it by starting from the last position with a negative index. By using the index -1, we get the last character an exclamation point. And if we use the index -2, we get the second to last character, A. Now that we've gone over the fundamentals of indexing, let's do some slicing. A string slice is a portion of a string. It's also known as a substring. String slices can contain more than one character. Here's an example of how we slice a string of the word orange. Let's start by putting some index numbers inside square brackets and separating the numbers by a colon. This defines the range of characters in the new slice. We'll go from index 1 up to index 4. The closing index is not included in the range that's returned to us, so this would capture indices 1, 2, and 3. And we've extracted a slice that contains the characters that correspond to these indices, R, A, N. We can also use slice notation with just one of the 2 indices. Omitting the first number in the range implies that the range begins at 0. So if the string is pineapple and we indicate our slice using :4, we'll capture the first 4 letters, pine. Similarly, if we slice using 4:, we'll capture everything beginning with index 4 all the way to the end, apple. Great. We have one more thing to learn. Sometimes data professionals want to check whether or not a substring is contained in a string. To check whether or not a substring is contained in a string, use the keyword in. Let's find out if banana is in the string contained in our fruit variable. It's false. There is no banana in our pineapple. But is there apple? Let's check. Yes, apple is a substring of pineapple, so the computer returns a value of true. Confirming whether a substring is contained in a string is a common practice in all kinds of data careers. I encourage you to take some time to go through the steps again on your own. The more you apply what you learn, the more comfortable you will become. As you're discovering, understanding strings is a big part of Python and programming success. Now that you have a foundational understanding of strings, let's learn some new approaches to save time when creating and manipulating strings. In this video, we'll focus on formatting strings using the format method. The format method formats and inserts specific substrings into designated places within a larger string. Let's examine how this appears in code. We have 2 variables, name and number. The format method uses the curly braces to designate where the variables should be inserted into the string. If we pass the variable names as parameters to the format method, we find that it doesn't matter that the name is a string and the number is an integer. The format method will insert strings of the values represented by these variables. The order that they're inserted in is the order that they're entered as parameters into the format method. In this case, name corresponds to the first set of braces and number corresponds to the second set. You can also be more explicit with how you designate what substring goes where. You can name your own keywords and insert them into the braces. In this case, we'll use name and num. Now we explicitly assign our variables to those keywords in the method parameters. When we run the cell, the values represented by the variables get inserted into the printed string according to their keywords. Notice that when we do it this way, the order that we enter the method arguments doesn't matter. Name will be inserted into the name field in the string, and number will be inserted into the num field of the string. This approach is very helpful, for example, in cases where an output message needs to be translated into another language. Many languages change the order of words to communicate the same message. This method makes rearranging strings fast and easy. And yet another way to insert values into strings is to use integer values in the braces to indicate the order in which to insert the arguments. Notice how in this example we can enter the variables number and name in the argument field in a different order than they get inserted into the printed string. As a data professional, these different ways to insert values into strings offer you a lot of flexibility in how you choose to work and solve problems. Here's an example that not only inserts substrings into a larger string, but also formats them. Imagine you want to print the price of an item with and without tax. Depending on the tax rate, the number might extend more than 2 places beyond the decimal. We can use string formatting to set a limit on the number of decimal places in the output, which makes it more readable. In this case, our item costs $7.75 without tax, and the tax rate is 7%, so the price with tax would be $8.2925. To limit the output to 2 places beyond the decimal point, we use special syntax. Start with a colon to separate the expression from the keyword name, if you decide to use one. After the colon, write .2f. .2 refers to 2 places beyond the decimal, and F stands for float. Now let's check what happens when we run this cell. Nice! The price with tax has 2 decimals now. You can replace the 2 in the expression to any number of places beyond the decimal you want. If you put 0, only a whole number will print. We're not done yet. There are even more ways to use the format function to improve expressions. Let's explore our conversion of temperature values from Fahrenheit to Celsius from earlier. At the top is the function we wrote to calculate the conversion. But now, instead of just printing the results, we'll format them too. Again, begin with a colon, then use the greater than operator to align the text to the right so that the output is neatly formatted. Greater than 3 will align the output 3 spaces to the right. For the converted Celsius value, we'll use greater than 6, which will align the Celsius temperatures 6 spaces to the right. Notice how clean the output is. Our decimals are cut at the hundredths place, and the values output in a nice table. Everything you've been learning about strings will help you work more effectively, streamline processes, and save your company lots of time and resources. Using Python is all about maximizing productivity while minimizing effort, making it the perfect tool to help you achieve these goals. This is the end of the third section of the Python course. You've come a long way since the beginning of the course. Congratulations on all your progress. In this section of the course, we focused on using Python code to automate repetitive tasks. Rather than write new code each time you want the computer to repeat an action, you can instead write an iterative statement, or loop. Loops automatically repeat a portion of the code until a process is complete. Using Python to automate repetitive tasks will help you work more effectively, streamline processes, and save tons of time and effort. As a data professional, you'll have more time available for your most important task, analyzing data to generate useful insights for stakeholders. We discussed 2 different approaches to automating repetitive tasks, while loops and for loops. You learned how to write code for both while and for loops and when to use each approach. We also discussed strings, or sequences of characters like letters and punctuation marks. You learned how to manipulate strings by slicing, indexing, and formatting them. As a data professional, you'll often work with textual data such as product information or customer feedback. Operations like slicing and indexing enable you to select, filter, and edit data quickly and efficiently. Learning Python is an exciting journey that will continue throughout your future career. Each data project that I work on has its own specific challenges. I'm always exploring online or chatting with teammates to learn new Python skills on the job. This helps me solve problems and work more efficiently. As you continue learning and practicing Python, your data analytics skill set will continue to grow. Coming up, you have a graded assessment. To prepare, review the reading that lists all the new terms you've learned, and feel free to revisit videos, readings, and other resources that cover key concepts. You're doing great. Keep it up. Hello again. You've come so far on your learning journey. Just think of all the new Python skills you've developed along the way. You've learned how to use variables to store and label your data, and how to work with different data types, such as integers, floats, and strings. You can call functions to perform actions on your data, and use operators to compare values. You also know how to write clean code that can be easily understood and reused by other data professionals. You can write conditional statements to tell the computer how to make decisions based on your instructions. And recently, you learned how to use loops to automate repetitive tasks. Coming up, we'll explore data structures, which are collections of data values or objects that contain different data types. Data professionals use data structures to store, access, organize, and categorize their data with speed and efficiency. Knowing which data structures fit your specific task is a key part of data work and will help streamline your analysis. We'll focus on data structures that are among the most useful for data professionals: lists, tuples, dictionaries, sets, and arrays. Part of what makes Python such a powerful and versatile programming language are the libraries and packages that are available to it. After we review fundamental data structures, we'll discuss 2 of the most important libraries and packages for data professionals. The first is numerical Python, or NumPy, which is known for its high-performance computational power. Data professionals use NumPy to rapidly process large quantities of data. I often use NumPy in my job because it's so useful for analyzing large and complex data sets. The second is Python Data Analysis Library, or Pandas, which is a key tool for advanced data analytics. Pandas makes analyzing data in the form of a table with rows and columns easier and more efficient because it has tools specifically designed for the job. When you're ready, I'll meet you in the next video. Great to be with you again. In this video, we'll discuss the differences between data types and data structures. Then we'll explore lists, which are a specific kind of data structure. As you've learned, a data type is an attribute that describes a piece of data based on its values, its programming language, or the operations it can perform. In the context of Python, this includes the classes, integers, strings, floats, and Boolean expressions, among others. A data structure is a collection of data values or objects that can contain different data types. So data structures can contain data type elements, such as a float or a string. Data structures also enable more efficient storage, access, and modifications. They allow you to organize and categorize your data, relate collections of data to each other, and perform operations accordingly. One data structure in Python is a list. A list is a data structure that helps store, and if necessary, manipulate an ordered collection of items, such as a list of email addresses associated with a user account. A list is a lot like a string, and you can do many of the same things with lists. For example, both strings and lists allow duplicate elements, as well as indexing and slicing. Additionally, both are sequences. A sequence is a positionally ordered collection of items. However, strings are sequences of characters, while lists store sequences of elements of any data type. There are some other key differences between lists and strings. First, note that different data structures are either mutable or immutable. Mutability refers to the ability to change the internal state of a data structure. Immutability is the reverse, where a data structure or element's values can never be altered or updated. Lists and their contents are mutable, so their elements can be modified, added, or removed. But strings are immutable. Think of a list like a long box with the space inside divided into different slots. Each slot contains a value, and each value can store data. This could be another data structure, such as another list, or an integer, string, float, or output from another function. When working with lists, you use an index to access each of the elements. Recall that an index provides the numbered position of each element in an ordered sequence. In this case, our sequence is a list. Let's go through an indexing example together. First, assign the following list of words to a variable x. Now, we are cooking with 7 ingredients. In Python, we use square brackets to indicate where the list starts and ends, and commas to separate each element contained in it. To print an element of a list, use its index number. So, to print the word cooking, print the third element of the list variable x. This is just like focusing on a specific character or substring in a string. The first element in a list, as with strings, is 0. So, if we print the element with slot number 3, we get the item or word cooking from our list of 7 words. Remember that indexing always starts at 0. So if we had typed 7 to try to access the last word of our list, we'd get an index error. We can also use indices to create a slice of the list. For this, use ranges of 2 numbers separated by a colon. To get the second and third words of our list, we and are. You can also use a :2 to get all words until the index slot 2. We get now and we, which have index slots 0 and 1. And to leave one of the range indexes empty, use 2:. This will give us the other part of the list. So, just as with string indexing, the first value for the first element in a list defaults to 0. And the second value, if left empty, defaults to the length of the list. To check if a list of words contains a certain element, like the word this, use the keyword in to generate a Boolean statement. This verifies whether the word exists. The result of this check is a Boolean, which we can then use as a condition for branching or looping in the rest of the code. Lists are very useful when you're working with many related values. They enable you to keep the right data together, simplify your code, and perform the same operations on multiple values at once. Coming up, we have even more on lists. In this video, we'll continue with lists. You'll learn how to modify the contents of a list. This will give you greater control over your lists because you can add, remove, and change the items that they contain. Previously, we thought about a list as a box divided into different slots. Modifying it means we can keep the box, but we add, remove, or change what's inside. When thinking about modifying lists, there are a few methods that can be used. We'll begin with the append method. The append method adds an element to the end of a list. This requires one argument because this function adds the incoming element to the end of the list as a single new entry. You can even start with an empty list and all new elements will be added at the end. Let's explore an example. We'll begin by typing a list of fruits. Upon further inspection, it seems we forgot to add kiwi to the list. So we can use the append method to add it. This uses one parameter, in this case, the string kiwi. Another common method for modifying lists is insert, which requires two arguments: the index number of the element to be modified and the contents being put in that slot, such as a string or integer. Let's investigate how insert works. Insert is a function that takes an index as the first parameter and an element as the second parameter, then inserts the element into a list at the given index. Returning to our list of fruits, now orange is inserted at the second spot at index 1 in our fruit list. Let's add an element at the beginning of the list. In the first parameter, we'll put 0. Then type mango as the second element. To remove an element from a list, let's consider the remove method. Remove is a method that removes an element from a list. Similar to the append method, remove only requires one parameter. Now our fruit list no longer has a banana. If we try to remove an element that is not in the list, like strawberries, for example, we get a value error. Another common way to remove elements is with the pop method, which uses an index. Pop extracts an element from a list by removing it at a given index. So, to remove orange, pop the third element in the list with index number 2. Now, suppose that after removing orange, you decide to also remove pineapple and replace it with mango. Simply reassign its value. Reference the pineapple's items, index number 1, and replace it with mango. This renders the list without orange, because we already removed it, as well as mango, which replaced pineapple. Our fruits have changed a lot since we started, but it's always the same list, the same box. We've just modified what's inside. At this point, I want to address something that new learners of Python often wonder about. You'll recall that strings are immutable and lists are mutable. What this means exactly might not be clear at first. After all, didn't we have multiple videos about how to manipulate strings? A new example will help make this more clear. Whenever we modify a string, we always have to reassign the change back to the variable that contained the string. This is overwriting the existing variable with a brand new one. Notice that we can't say overwrite the character at index 0. We get an error. However, we can do this with a list. That's why lists are considered mutable. Great work modifying lists. Now, after all that talk about tasty fruit, I think we deserve a snack break. I'll catch up with you again very soon. As a data professional, sometimes it will be more important to access and reference data than to change and manipulate it. When you simply need to find some information, but keep the data intact, you can use a data structure called a tuple. A tuple is an immutable sequence that can contain elements of any data type. Tuples are kind of like lists, but they're more secure because they cannot be changed as easily. They're helpful because they keep data that needs to be processed together in the same structure. Tuples are instantiated or expressed with parentheses or the tuple function. Here, we have a tuple that represents someone's full name. Notice that it was instantiated using parentheses. The first element of the tuple is their first name, the second is the first letter of their middle name, and the third is their last name. The position of the element is fixed in tuples, so you can't add new elements in the middle, and you can't change any of the elements. If we try to change the last name, which lives in index number 2, from Hopper to Copper, the code will throw an error. You can add a value to the end, but only if you reassign the tuple. Another way we can create tuples is by using the tuple function to transform input into tuples. In this case, our name is represented as a list. We can convert the list to a tuple by using the tuple function. Notice that the name is no longer a list, so it doesn't have the brackets anymore. Tuples are also used to return values in functions. In fact, when a function returns more than one value, it's actually returning a tuple. For example, here's a function that takes as an argument a float value that represents a price. The function returns the number of dollars and cents. Notice that when we use the function to convert $6.55 to dollars and cents, the return value is represented as a tuple that contains two numbers. Interestingly, even though tuples are immutable, they can be split into separate variables. When we run the $2 function, we can directly assign the output into distinct variables. The information stored as a tuple in the result variable has now been reassigned to two separate variables that we can manipulate as we please. This process is known as unpacking a tuple. Notice that the unpacked variables themselves are no longer tuples. In this case, they're integers. A big advantage of working with tuples is that they let you store data of different types inside other data structures. Here's an example of how this might be useful. This is a list of the starting 5 players on a university women's basketball team. Each player is represented by a tuple that contains their name, age, and position. This is a useful way of working with this type of information. The order of the players doesn't matter that much, and we might want to add to or rearrange them, so we use a list, which is mutable. However, the players themselves are individual records that are represented by tuples. They are a bit more secure because tuples are immutable and more difficult to accidentally change. Because lists and tuples are iterable, we can extract information from them using loops. For example, we can write a for loop that unpacks each tuple into 3 separate variables and then prints one of the variables for each iteration. This is equivalent to looping over each player record and printing the record at index 0. Using tuples in data professional work helps make your processes more efficient. It saves memory and can really optimize your programs too. Plus, when others collaborate with you on your code, your use of tuples will make it clear to them that your sequences of values are not intended to be modified. This is yet another great way to save your team time and effort. Hello again. In this video, we'll consider more complex examples of different ways to work with loops, lists, and tuples. I'll also introduce a few new tools that are useful for data professionals. Let's return to the women's basketball team list of players from the previous video. In this example, we'll integrate string formatting, loops, tuples, and lists. Remember, we have a list of tuples where each tuple contains the name, age, and position of a player. Let's define a function that extracts the name and position of each player into a list that we'll use to print the information. We'll call the function playerPosition, and its argument will be a list of tuples that contain player information. Next, we'll instantiate an empty list that will hold our result, which we'll build as we loop through the data. Now we'll use a for loop to unpack the tuples in our list of players. The variables we assign in the for loop must align with the format of the tuples. There are 3 components of each tuple in our list: name, age, and position. So we need 3 variables in our for loop. If we tried to unpack the tuples using only two variables, like for name, age, and players, the computer would throw an error. It wouldn't know what to do because there are three elements of the tuple, but we're only giving the computer two containers to put them in. So we'll begin our for loop for name, age, position, and players. Then we'll use string formatting to append each name and position to the result list. Each string will include some positional formatting and a new line too. Finally, we'll call this function in a for loop. This for loop will iterate over the results list that is output by the function and print each one. Now we have a nicely formatted, easily readable table of players and positions. Here's another application of loops and lists. This is an example of nested loops. A nested loop is when you have one loop inside another loop. These loops create all the different domino tiles in a set of dominoes, which is a tile-based game played with numbered gaming pieces. Feel free to pause the video and try to figure out what's happening. We start with the numbers on the left side of the dominoes. These numbers represent the dots, or pips, on the domino. They range from 0 to 6. For each number in this range, we'll run another loop to generate the pips on the right side of the domino. Then, we insert the left number and right number into a formatted print statement. And here are the dominoes. Notice that in this first print statement, we've included a parameter called end, whose value was a white space. When a print statement executes, by default, it will end with a new line. So without this parameter, all the dominoes would have been printed in a vertical line, each one beneath the next. But when we set the end character to a white space, it prints a space between each domino instead. Here's the same code, but instead of printing the dominoes as strings, it stores each one as a tuple of integers in a list called dominoes. Now, suppose we want to check the second number of the tuple at index 4. We can do that by using indexing. Start with the list we want to access, dominoes, and put the index of the tuple we want to access in brackets. Then, add another pair of brackets containing the index of the value within that tuple. What if we want to calculate the total number of pips on each domino? We can do that with the for loop that iterates over each tuple, sums the value at index 0 and the value at index 1, and appends the sum to a list. But there's a much easier way of doing this. It's called a list comprehension. A list comprehension formulaically creates a new list based on the values in an existing list. Here's how it works. Begin by assigning a variable for a new list. We'll call this one pips from list comp. For its value, create an empty list. Now we basically write a for loop, only in reverse. We begin with the calculation that creates each element of the list. In this case, we want each element to be the total number of pips on the domino, which is the domino at index 0 plus the domino at index 1. Then we add a for statement. We can check to make sure it gave the same result as our for loop. They're the same. Note what happened. This is why I said a list comprehension is like a for loop written in reverse. The for part of it is at the end of the statement, and the computation is at the beginning. Both the for loop and the list comprehension do the same thing, but the list comprehension is much more elegant and usually faster to execute too. Hopefully by now, you can appreciate how powerful the building blocks of Python can be. I encourage you to explore this notebook on your own and play with the code to discover what happens when you add something here or change something there. Playing with code is one of the best ways to learn. I'll see you soon. Dictionaries are one of the most widely used and important data structures in Python. A dictionary is a data structure that consists of a collection of key value pairs. They are instantiated with braces, or the dict function. We'll discuss that more shortly. Both veteran and entry-level data professionals use dictionaries to analyze large data sets with fast processing power. This helps them gather and transform user information. Dictionaries also provide a straightforward way to store data making it easier for users to find specific information. To use a regular dictionary, not the data structure, but the actual book with words and definitions, you look up a word, find it, then read its definition. It's essentially the same with the Python dictionary. You look up a key, which will let you access the values associated with that key. That's what's meant by key-value pairs. Here's a simple example to illustrate the concept. Suppose we have a zoo, and the zoo has different pens that contain different animals. We could have a dictionary that stores this information for us, with the pen numbers as keys and the animals as values. We could use this dictionary to look up which animals are in each pen. For example, if we want to know what animals are in pen 2, we type the name of the dictionary, zoo, followed by the pen in brackets. Accessing a dictionary this way always searches over the keys and returns the values of the corresponding key. It doesn't work the other way around. I can't use indexing to search for zebras and find out their pen. I will get a key error, because zebras is not a key in the dictionary. Dictionaries are instantiated mainly in two ways. The first way is with braces. With this approach, each key is separated from its value by a colon, and each key-value pair is separated from the next by a comma. The second way to create a dictionary is with the dict function. When using the dict function, the syntax is a little different. When the keys are strings, you can type them as keyword arguments. The last time we made this dictionary, we used quotation marks to indicate that the keys were strings. Here, we don't, because they're keyword arguments. Also, instead of using a colon between the keys and their values, you use an equal sign. The dictionary lookup is the same, irrespective of whether braces or the dict function is used. The dict function is also a little more flexible in how it can be used. For example, we can create this same dictionary once again by passing a list of lists as an argument, or even a list of tuples, a tuple of tuples, or a tuple of lists. They all give us the same result. If we want to add a new key-value pair to an existing dictionary, say, to put crocodiles in pen 4, we can assign it like this. A dictionary's keys must be immutable. Immutable keys include, but are not limited to, integers, floats, tuples, and strings. Lists, sets, and other dictionaries are not included in this category since they are mutable. Another important thing to note about dictionaries is that they're unordered. That means you can't access them by referencing a positional index. If I try to access our zoo dictionary at index 2, I get a key error, because the computer is interpreting the 2 as a dictionary key, not as an index. Also, because dictionaries are unordered, you'll sometimes find that the order of the entries can change as you're working with them. If the order of your data is important, it's better to use an ordered data structure like a list. Finally, you can check if a keyword exists in your dictionary simply by using the in keyword. Note that this only works for keys. You can't check for values this way. There's a lot that we can do with dictionaries, and what we've reviewed here is only the beginning. Next, we'll consider more examples that show the power of dictionaries. You'll also learn about some tools that make working dictionaries easy and convenient. Meet you there. Previously, you were introduced to dictionaries and learned a little bit about how they work. Let's continue our exploration of dictionaries and how to use them. Let's consider a previous example and revisit the women's basketball team roster. Recall that the roster was encoded as a list of tuples. Each tuple represented the name, age, and position of a player on the team. The list of tuples was useful when we had a single team and one player per position. What if we add more players beyond the starting 5? A dictionary can help us organize their data according to our specific needs. For example, what if we want to be able to look up players by their position? We can create a dictionary where the positions are the keys and the players are the values, each represented as a tuple that contains 2 values, their name and age. We could retype the information into a dictionary or cut and paste it, But if you find yourself doing these things, you can take this as an opportunity to improve your coding skills. Consider that this is the information for just 10 players. What if we had data for the whole league? We can convert this information to a dictionary with a for loop and some conditional logic. We'll begin by instantiating an empty dictionary and assigning it to a variable named new team. The idea is to loop over each tuple in the list, extract the position and assign it as a dictionary key, and extract the player's name and age and assign them as a tuple within a list, representing the value for that key. The process would repeat for each iteration of the loop until all of the players are recorded in the dictionary. Notice that each position is only represented once as a key, so the final dictionary has 5 keys, and there are 2 players in the list at each key's value. Now let's write the loop. First, we'll assign the empty dictionary to a variable called new team. Then, we'll write a for loop that unpacks the information in the original tuples for name, age, position, and team. And here's where the conditional logic comes in. If the position already exists as a keyword in our dictionary, then we want to append the name and age tuple to the list of tuples. Remember, the value for each key will be a list that contains tuples of player information. If the position does not already exist as a keyword in the dictionary, we'll have to assign it. We'll use an else statement to do this. With only a few lines of code, we have converted our list of tuples to a dictionary. Let's check that it works. It sure does. Creating dictionaries this way is a common practice in data analytics with Python. So learning this process will help make you a more capable data professional. Now, let's learn about some useful methods that we can use on dictionaries to really take advantage of their power. Specifically, we'll discuss the keys, values, and items methods. If you run a loop over a dictionary, the loop will only access the keys, not the values. For example, if we loop over the dictionary we just created and print each iteration, the computer will return 5 positions, the keys of the dictionary. But you don't need to write a loop every time you want to access the keys of your dictionary. That's what the keys method is for. The keys method lets you retrieve only the dictionary's keys. Returning to our new team dictionary, when we apply the keys method to the dictionary, the computer returns a list of all its keys. Similarly, the values method lets you retrieve only the dictionary's values. When applied to our new team dictionary, we get the values returned as a list. Since our values are lists of tuples, it means the result of calling this method is a list of lists of tuples. But what if you want to access both the keys and their values? You can, using the items method, which lets you retrieve both the dictionary's keys and values. Let's use a loop to print what the items method returns so the output is prettier. Dictionaries make storing and retrieving data fast and efficient. Keep exploring the many things you can do with them. With time, you'll find that they become an important tool in your data analytics toolbox. Welcome back. In this video, we're going to discover sets. A set is a data structure in Python that contains only unordered, non-interchangeable elements. Sets are instantiated with the set function or non-empty braces. Each set element is unique and immutable. However, the set itself is mutable. Sets are valuable when storing mixed data in a single row or record in a data table. They're also frequently used when storing a lot of elements, and you want to be certain that each one is only present once. Because sets are mutable, they cannot be used as keys in a dictionary. There are 2 ways to create a set. The first way is with the set function. The set function takes an iterable as an argument and returns a new set object. Let's examine the behavior of sets by passing lists, tuples, and strings through the set function. To turn the list containing foo, bar, baz, and foo into a set, pass a list through the set function. And notice the list loses the second foo. As I've mentioned, Each element must be unique in sets. Pass a tuple through the set function using two sets of parentheses, one to tell the computer that the data we are working with is a tuple, the other because the set function only takes a single argument. Again, the same result, only one foo element can be present in the set. Finally, pass a string through the set function. It doesn't return the string, just the singular occurrence of the letters in the string, O and F, in an unordered way. This is because the set function accepts a single argument, and that argument must be iterable. A string is iterable, so the set function splits it into individual characters and keeps only the unique ones. The second way to instantiate a set is with braces. However, you have to put something inside the braces. Otherwise, the computer will interpret your empty braces as a dictionary. Note here that instantiating a set with braces treats what's inside the braces as literals. So, when instantiating a set of only a single string using braces, it returns a set with a single element, and the element is the string itself. Remember, to define an empty set or a new set, it is best to use the set function. You can only use curly braces when the set is not empty and you are assigning the set to a variable. Also, keep in mind that because the elements inside a set are immutable, a set cannot be indexed or sliced. Now, let's discuss some additional functions you can use on sets. First, intersection finds the elements that two sets have in common. Union finds all the elements from both sets. Difference finds the elements present in one set, but not the other. And symmetric difference finds elements from both sets that are mutually not present in the other. Python provides built-in methods for performing each of these functions. Let's start with the intersection method, denoted by the ampersand. First, define two sets. Then, apply the intersection function, either by attaching the intersection method to set 1 and passing set 2 to the method's argument, or by using the ampersand operator. Great. Now, let's apply the union function. Use braces to define the two sets, x1 and x2. The goal is to observe where they overlap. Print them using the union method on the x2 variable or the union operator symbol. Union is a communicable operation in mathematics, so the overlapping values will be the same no matter what order you put your variables in. The difference operation on sets, however, is not a communicable operation. Just like in math, if you subtract 5 from 7, you get a different result than if you subtract 7 from 5. You can use either the difference method or the minus sign as a set operator. Subtracting set 2 from set 1 gives us only the elements in set 1 that are not shared with set 2. But we don't know if set 2 contains any elements that are not shared with set 1. The inverse is also true. Subtracting set 1 from set 2 gives us only the elements in set 2 that are not shared with set 1. But we don't know if set 1 contains any elements that are not shared with set 2. To get around this and observe the difference between two sets mutually, use the symmetric difference function. As you might have guessed, you can use the symmetric difference method or the symmetric difference operator expressed by a caret. Symmetric difference outputs all the elements that the two sets do not share. Excellent work with sets in Python. You've learned so much in this section of the course already, and everything you're learning is preparing you for a really rewarding career working with data. Can't wait to be with you soon again. Python has many advanced calculation capabilities that are used for data work and other scientific applications. These features make it possible to extend, enhance, and reuse parts of the code. To access these features, you can import them from libraries, packages, and modules. These features are not included in basic Python, so it's necessary to add them to your scripts. The additional functionality can save you time constructing functions and objects in your own work. Using these features can also help you obtain extra data types for analyzing data or building machine learning models. Let's start with libraries. A library, or package, broadly refers to a reusable collection of code. It also contains related modules and documentation. You'll often encounter the terms library and package used interchangeably. Commonly used libraries for data work are matplotlib and Seaborn. Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. Seaborn is a data visualization library that's based on Matplotlib. It provides a simpler interface for working with common plots and graphs. This certificate program integrates two other commonly used libraries for data work, NumPy and Pandas. NumPy, or numerical Python, is an essential library that contains multi-dimensional array and matrix data structures and functions to manipulate them. This library is used for scientific computation. And Pandas, which stands for Python Data Analysis, is a powerful library built on top of NumPy that's used to manipulate and analyze tabular data. There are many other popular Python libraries and packages for data professional work, such as scikit-learn, stats models, and others. Scikit-learn, a library, and stats models, a package, consist of functions data professionals can use to test the performance of statistical models. They're used across various scientific fields. Scikit-learn and stats models are pretty advanced, so you won't be working with them in this course, but you'll have opportunities to work with these libraries elsewhere in the program. Again, different practitioners across the field often conflate libraries and packages, so you may hear them referred to one, the other, or both ways. Libraries and packages provide sets of modules that are essential for data professionals. Modules are accessed from within a package or a library. They are Python files that contain collections of functions and global variables. Global variables differ from other variables because these variables can be accessed from anywhere in a program or script. Modules are used to organize functions, classes, and other data in a structured way. Internally, modules are set up through separate files that contain these necessary classes and functions. When you import a module, you are using pre-written code components. Each module is an executable file that can be added to your scripts. Commonly used modules for data professional work are math and random. Math provides access to mathematical functions, and random is used to generate random numbers. This is useful when selecting random elements from a list, shuffling elements randomly, or working with random sampling, which you'll explore in a later course. There are several ways to import modules, depending on whether you want to use the whole package or just a single predefined function or feature. This adds functionality for carrying out specialized operations. There's lots more to learn about libraries, packages, and modules, so feel free to refer to the course resources for more information on installing these features and to continue growing your Python knowledge. But as a reminder, you don't have to install anything because everything you need to complete the different sections of the certificate program are already built into the notebooks you'll be using in Coursera. I'll introduce you to some libraries in the next video. You've learned that part of what makes Python such a powerful and dynamic language are the packages and libraries that are available to it. One of the most widely used and important of these is NumPy. Recall that NumPy contains multi-dimensional array and matrix data structures, as well as functions to manipulate them. You'll learn more about these data structures and functions soon, but for now, let's just consider NumPy at a high level and learn more about it. NumPy's power comes from vectorization. Vectorization enables operations to be performed on multiple components of a data object at the same time. This is particularly useful for data professionals because their jobs often involve working with very large quantities of data, and vectorized code saves a lot of time because it computes more efficiently. Let's explore this a little more. Suppose we have list A and list B, both the same length, and we want to create a new list C that's the element-wise product of each list. In other words, we want to multiply the first element of list A by the first element of list B, Then multiply the second element of list A by the second element of list B, etc. If we try to multiply lists A and B together, the computer throws an error. To perform this operation, we could write a for loop. We'd start by defining an empty list, list C, then make a range of indices to loop over and append the product of list A and list B at each index to list C. This gets the job done, but if you're thinking there's got to be an easier way, you're right. We can use NumPy to perform this operation as a vectorized computation. Simply convert each list to a NumPy array and multiply the two arrays together using the product operator. The results are the same, but the vectorized approach is simpler, easier to read, and faster to execute because while loops iterate over one element at a time, vector operations compute simultaneously in a single statement. The efficiency of this might not be noticeable now, but when working with large data sets, it will be. Vectors also take up less memory space, which is another factor that becomes important when working with a lot of data. You might have noticed that when we used NumPy, we first had to import it. This is called an import statement. An import statement uses the import keyword to load an external library, package, module, or function into your computing environment. Once you import something into your notebook and run that cell, you don't need to import it again unless you restart your notebook. When we import NumPy, we import it as NP. This is known as aliasing. Aliasing lets you assign an alternate name or alias by which you can refer to something. In this case, we're abbreviating NumPy to NP. Notice the NPs in the code below the import statement where we create our arrays. If we didn't give NumPy an alias of NP, we'd have to type out NumPy here in order to access its array function. Aliasing as NP makes the code shorter and easier to read. Note that NP is the standard alias. If you use something else, other people might get confused when reading your code. In addition to being highly useful in its own right, NumPy powers a lot of other Python libraries, like Pandas, so understanding how NumPy works will help you use these other packages. There's a lot more to discover about NumPy. Coming up, you'll learn about its core data structures and functionalities. See you soon. Welcome back. You recently learned that the NumPy library uses vectorization to make working with data faster and more efficient, which makes your job easier. I demonstrated how NumPy performed an element-wise multiplication of two lists by converting the lists to arrays and then simply multiplying them together. Now, we're going to continue learning about arrays and how to work with them. The array is the core data structure of NumPy. The data object itself is known as an n-dimensional array, or ND array for short. The ND array is a vector. Recall that vectors enable many operations to be performed together when the code is executed, resulting in faster runtimes that require less computer memory. You can create an ND array from a Python object by passing the object to the nparray function. ND arrays are mutable, so you can change the values they contain. If I want to change this last value from a 4 to a 5, I can do that by identifying the index number. Since we're dealing with the last value here, it's necessary to use a -1. But I can't change the size of the array without reassigning it. If I try to add a number to the end of this array, the computer throws an error. So if you want to change the size of an array, you have to reassign it. Another requirement of the array is that all of its elements be of the same data type. If I create an array with the integers 1, 2, and then a string of coconut, NumPy will create an array that forces everything to the same data type, if possible. In this case, everything becomes a string, represented here by U21, meaning Unicode 21. So be careful when creating your arrays that they all contain data of the same type, or if they don't, that this is intentional and useful to what you're doing. You previously learned that calling the type function on an object will return the data type of the object. If we do that with an array, as you might expect, we get a NumPy array. We can use the dtype attribute if we want to check the data type of the contents of an array. Here, the dtype attribute indicates that this array consists of integers. As the name implies, ND arrays can be multidimensional. For a one-dimensional array, NumPy takes an array-like object of length x, like a list, and creates an ND array in the shape of x. A one-dimensional array is neither a row nor a column. We can use the shape attribute to confirm the shape of an array. We can also use the ndim attribute to confirm the number of dimensions the array has. Data professionals will often need to confirm the shape and number of dimensions of their array. For example, if they're trying to attach it to another existing array. These methods are also commonly used to help understand what's going wrong when your code throws an error. A two-dimensional array can be created from a list of lists, where each internal list is the same length. You can think of these internal lists as individual rows, so the final array is like a table. Notice that this array has a shape of 4 rows by 2 columns and is 2 dimensions. If a two-dimensional array is a list of lists, then a three-dimensional array is a list that contains 2 of these, so a list of 2 lists of lists. This array can be thought of as 2 tables, each with 2 rows and 3 columns. Thus, it has 3 dimensions. This can go on indefinitely. Thankfully, there are ways to help simplify working with multidimensional arrays, which you'll learn about later. And unless you're doing very advanced scientific computations, you typically won't be working directly with NumPy arrays that are more than 3 dimensions. NumPy also lets us reshape an array using the reshape method. Our two-dimensional array was 4 rows and 2 columns. But what if we wanted this data to be 2 rows by 4 columns? We just plug these values into the reshape method and reassign the result back to the array2D variable. Reshaping data is a common task in data analysis, so it's important for you to be familiar with what it means and how it works. There are many other operations that can be performed with arrays, and you'll surely learn those as the need for them arises in your projects. But there are other helpful functions and methods in NumPy that you'll use regularly. These include functions to calculate things like mean and natural logarithm, and floor and ceiling operations, which round numbers to the nearest lesser and greater whole number, respectively, and many other frequently used mathematical and statistical operations. NumPy is very robust. There are so many things you can do with it that we can only briefly consider them here. As you know, NumPy powers many other useful libraries and packages. In this certificate program, we won't be working a lot directly with NumPy, but we will be working a lot with the library that depends on it, Pandas. It's important that you understand the basics of NumPy because it will help you when you start working with Pandas. As you develop your skills as a data professional, you'll find yourself returning to NumPy time and time again because it's such an integral part of advanced data analysis. Bye for now. Hi there. We previously discussed NumPy and how it's an important tool for data professionals and anyone else whose job requires high-performance computational power. We also investigated how other libraries and packages use NumPy because of the efficiencies that come with vectorization. One of these libraries is Pandas, a quintessential tool both in this certificate program and in the world of data analytics. In this lesson, you're going to learn more about Pandas and why it's so useful. Because Pandas is a library that adds functionality to Python's core toolset, you have to import it. Similar to how we imported NumPy as NP, Pandas has its own standard alias of PD. Typically, when using Pandas, you import both NumPy and Pandas together. This is just for convenience, given that NumPy is often used in conjunction with Pandas. Strictly speaking, you don't have to import NumPy to work in Pandas. Pandas is fully operational on its own. Pandas' key functionality is the manipulation and analysis of tabular data. That is, data that's in the form of a table with rows and columns. A spreadsheet is a common example of tabular data. While NumPy is capable of many of the same functions and operations as Pandas, it's not always as easy to work with because it requires you to work more abstractly with the data and keep track of what's being done to it, even if you can't see it. Pandas, on the other hand, provides a simple interface that allows you to display your data as rows and columns. This means that you can always follow exactly what's happening to your data as you manipulate it. In this video, I'll give you a demonstration of Pandas and what it's like to use it. Later, we'll go into greater detail on its unique classes, processes, and functions. First of all, you can load data into Pandas easily from different formats like comma-separated value files, or CSVs, Excel and other spreadsheets, databases, and more. Here, I'm loading a CSV file that I'm accessing via a web URL. The file contains information for some of the passengers from the Titanic, including their names, what class ticket they had, their age, ticket price, and cabin number. By the way, this table of data is called a data frame. The data frame is a core data structure in Pandas. Notice that the data frame is made up of rows and columns, and it can contain data of many different data types, including integers, floats, strings, booleans, and more. If I want to calculate the average age of the passengers, we do so by selecting the age column and calling the mean method on it. I can also get the max, min, and standard deviation with minimal effort. I can also quickly check how many passengers were in each class. Checking summary statistics of the entire dataset only requires one line of code. This method gives me the number of rows, as well as the mean, standard deviation, minimum, and maximum values, along with the quartiles for every numeric column. These concepts are all covered in greater depth elsewhere in the program. For now, I just want you to pay close attention to the power of Pandas and all that you can accomplish with it. Pandas also allows me to filter based on simple or complex logic. For example, here I'm selecting only the third-class passengers who were older than 60. In addition to all of these data analysis tools, Pandas also gives us ways to manipulate and change the data. For example, I can add a column that represents the inflation-adjusted price of a ticket from 1912 to 2023. Florence Briggs Thayer paid £71.28 for her first-class ticket. Today, that ticket would have cost her £10,417 sterling. If you're wondering how I knew her name was Florence Briggs Thayer, it's because I can also select rows, columns, or individual cells from the data using indexing. Her name is in row 1, column 3. I can also do more complex data groupings and aggregations. For example, here I'm grouping the passengers by class and sex, and then calculating the mean cost of a ticket for each group. Hopefully you're excited to start working with Pandas. I know I'm looking forward to guiding you as you learn more about this powerful and fun data analysis tool. Now that you have a good understanding of the core structures and routines of Python and some of the basics of NumPy, you're ready to start working with Pandas. Pandas is one of the primary tools that you'll use throughout the rest of the certificate program, as well as in a large and growing number of data professions. In this video, you'll learn about the main classes in the Pandas library and some important ways to work with them. Pandas has two core object classes, data frames and series. Let's begin with the review of data frames. A data frame is a two-dimensional, labeled data structure with rows and columns. You can think of a data frame like a spreadsheet or a SQL table. It can contain many different kinds of data. Data professionals use data frames to structure, manipulate, and analyze data in Pandas, just like we did in the previous video with the Titanic example. We can create a data frame using the Pandas data frame function. This function has a lot of flexibility and can convert numerous data formats to a data frame object. In this example, we created a data frame from a dictionary where each key of the dictionary represents a column name, and the values for that key are in a list. Each element in the list represents a value for a different row at that column. We can also create one from a NumPy array, resembling a list of lists, where each sublist represents a row of the table. Notice that in this example, we included separate keyword arguments for columns and index. This approach lets us name the columns and rows of the data frame. These are just a couple of the many different ways to create a data frame with the data frame function. For examples of some others, be sure to review the available Pandas documentation on this topic. Often, data professionals need to be able to create a data frame from existing data that's not written in Python syntax. For example, maybe we want to take an existing spreadsheet and manipulate it in Pandas. Spreadsheets can be saved as CSV files, which can then be read into Pandas as a data frame. CSV stands for comma-separated values, and it refers to a plain text file that uses commas to separate distinct values from one another. Here is a sample of the first few lines of a source data from the Titanic dataset that we used previously. This is what a CSV file looks like. In this file, you'll find values for passenger name, age, sex, fare, and more. Notice that a comma is used to separate each value from the next. To create a data frame from a CSV file, Pandas has the read CSV function. Here's the same Titanic data rendered as a data frame. For the sake of an example, it's defined here as df3. The read CSV function can read files from a URL, like in this example, and it can also read files directly from your hard drive. Instead of a URL, you just provide the file path to your file. Now, let's discuss the other main class in Pandas, series. A series is a one-dimensional labeled array. Series objects are most often used to represent individual columns or rows of a data frame. So, if we select a row or a column from this Titanic data frame and call type on it, it will return as a Pandas series object. Like data frames, individual series can be created from various data objects, including from NumPy arrays, dictionaries, and even scalars. Again, refer to the Pandas documentation for examples. Now, let's use the Titanic dataset to review some of the basics of working with data frames and series. The data frame and series classes have many super useful methods and attributes that make common tasks easier. Remember, a method is a function that belongs to a class. It performs an action on the object. An attribute is a value associated with a class instance. It typically represents a characteristic of the instance. Both methods and attributes are accessed using dot notation, but methods use parentheses, while attributes do not. Earlier in the video, we named the Titanic dataset df3. But let's change the name to Titanic for clarity. We can do this by simple reassignment. If we want to access the columns of the data frame, we can use the columns attribute. This returns an index of all of the column names. We can use the shape attribute to check the number of rows and columns contained in the data frame. This data frame has 891 rows and 12 columns. And we can get some summary information about the data frame by calling the info method. This tells us that there are 891 rows and 12 columns, and it also gives us the column names, the data type contained in each column, the number of non-null values in each column, and the amount of memory the data frame uses. By the way, I want to address a couple of points about terminology in Pandas. First, null values in Pandas are represented by NaN, which stands for not a number. And second, if a series object contains mixed or string data types, when you check its data type, it will come back as an object. This is an example of how Pandas is built on NumPy, but the details of this are beyond the scope of this video. One of the most common tasks when working in Pandas is selecting or referencing parts of a data frame. This has many similarities with indexing and slicing. For example, if you want to select a single column, you can type the name of the data frame followed by brackets, and within the brackets, enter the name of the column as a string. This returns a series object of that column. You can also use dot notation, but this only works if the column name does not contain any white spaces. Using dot notation is faster to type, so for very simple lines of code, you may prefer to do this, but if the code begins to get more complex, it's generally better to use bracket notation because it makes the code easier to read. To select multiple columns of a data frame by name, use bracket notation. Within the brackets, enter a list of column names. This returns a view of your data frame as a new data frame object. If you want to select rows or columns by index, you'll need to use iloc. Iloc is a way to indicate in Pandas that you want to select by integer location-based position. If you enter a single integer into the iloc brackets, you'll get a series object representing a single row of your data frame at that index. Because I entered 0 here, I got the very first row in my data frame as a series. If you enter a list of a single integer in the iloc brackets, you'll get a data frame object of a single row of the data frame at that index. You can access a range of rows by entering the indices of the beginning and ending rows separated by a colon. Pandas will return every index starting with the beginning index up to but not including the last index. So 0:3 returns row indices 0, 1, and 2. You can select subsets of rows and columns together too. This returns a data frame view of rows 0, 1, and 2 at columns 3 and 4 only. So, if you want a single column in its entirety, you select all rows and then enter the index of the column you want. And you can even get a single value at a particular row in a particular column by using two indices separated by a comma. Loc is similar to iloc, but instead of selecting by index location, loc is used to select Pandas rows and columns by name. Let's investigate loc with the Titanic data frame. In this example, I'm selecting rows 1, 2, and 3 at just the name column. Note that in this example, we're referring to the rows with numbers, even though we're using loc to select. This is because our rows are indexed by number. If we had a named index, however, we'd have to use row names, like what we're doing for columns. And one more thing, if you want to add a new column to a data frame, you can do that with a simple assignment statement. Now we have a new column at the end here. There are so many things you can do in Pandas, and I can only share so much in the time we have. As always, the documentation is your friend. There will inevitably be times where you need to do something that wasn't explicitly covered here. In those cases, the documentation almost always has simple examples that demonstrate how to do the thing you need to do. There's still more to come though, so I'll meet you soon. Previously, we investigated several different ways of selecting data in a data frame, including column selection, row selection, and selection of combinations of rows and columns using name-based and integer-based indexing. In this video, you'll learn how to filter the data in a data frame based on value-based conditions. You know that Boolean is used to describe any binary variable with two possible values, true or false. With Pandas, you can use a powerful technique known as Boolean masking. Boolean masking is a filtering technique that overlays a Boolean grid onto a data frame in order to select only the values in the data frame that align with the true values of the grid. Data professionals use Boolean masking all the time, so it's important that you understand how it works. Here's an example. Suppose you have a data frame of planets, their radii, and the number of moons each planet has. Now suppose that you want to keep the rows of any planets that have fewer than 20 moons and filter out the rest. A Boolean mask is a Pandas series object indicating whether this condition is true or false for each value in the moons column. The data contained in the series is type bool. Boolean masking effectively overlays this Boolean series onto the data frame's index. The result is that any rows in the data frame that are indicated as true in the Boolean mask remain in the data frame, and any rows that are indicated as false get filtered out. Here's how to perform this operation in Pandas. We'll begin by creating a data frame from a predefined dictionary using the Pandas data frame function. The data frame is called planets. The next step is to create the Boolean mask by writing a logical statement. Remember, the objective is to keep planets that have fewer than 20 moons and to filter out the rest. So we define the mask by writing planets at the moons column is less than 20. This results in a series object that consists of the row indices where each index contains a true or false value, depending on whether that row satisfies the given condition. This is the Boolean mask. To apply this mask to the data frame, insert it into selector brackets and apply it to the data frame. It's also possible to apply the conditional logic directly to the data frame, skipping the part where we assign it to a variable named mask. But breaking out the steps individually can make the code easier to follow. Note that we haven't permanently modified the data frame. Applying the Boolean mask using the conditional logic only gives a filtered view of it. So when you call the planets variable again, it returns the full data frame. However, we can assign the result to a named variable. This may be useful if you'll need to reference the list of planets with moons under 20 again later. Sometimes you'll need to filter data based on multiple conditions. Pandas uses logical operators to indicate which data to keep and which to filter out in statements that use multiple conditions. These operators are the ampersand for and, the vertical bar for or, and the tilde for not. Let's review how this works. Here's how to create a Boolean mask that selects all planets that have fewer than 10 moons or greater than 50 moons. Notice that each condition is self-contained in a set of parentheses, and the two conditions are separated by a vertical bar, which is the logical operator that represents or. It's very important that each component of the logical statement be in the parentheses. Otherwise, your statement will throw an error, or worse, return something that isn't what you intended. To apply the mask, call the data frame and put the statement or the variable it's assigned to in selector brackets. Here's an example of how to select all planets that have more than 20 moons, but not planets with 80 moons and not planets with a radius less than 50,000 kilometers. Let's break it into pieces. First is the statement for planets. In parentheses, we put planets at the moons column must be greater than 20 and close the parentheses. Then we use the and not operators before parentheses. Planets at the moons column equals 80, close parentheses. Then we again use the and not operators before parentheses. Planets at the radius column less than 50,000, close parentheses. When we apply the mask to the data frame, we're left with just one planet, Saturn, with 83 moons and a radius of 58,232 kilometers. There are a near infinite number of ways to select and filter data using the basic tools that you've learned so far. As always, it takes a lot of practice before you know exactly how to execute every selection statement that your work requires. so make sure to bookmark any and all resources that you find helpful to reference. Keep up the good work, and I'll meet you in the next video. Now that you've learned how to select and filter data using name and location-based indexing, as well as Boolean masking, it's time to take the next step. In this video, you'll learn how to group your data, aggregate it, and perform calculations on these groupings to help you discover what the data is telling you. One of the most important and commonly used tools to group data in Pandas is the group by method. Group by is a Pandas data frame method that groups rows of the data frame together based on their values at one or more columns, which allows further analysis of the groups. Let's return to our planets dataset to demonstrate some different ways to use the group by method. This time, we'll add a little more data, including the type of planet, whether or not it has a ring system, average temperature in degrees Celsius, and whether or not it has a global magnetic field. As always, when learning a new data tool, it's helpful to begin by applying it to a small example. This will better enable you to understand exactly what's happening. First, let's examine the mechanics of what happens when you use group by. When you call the group by method on a data frame, it creates a group by object. If you do nothing else, the group by object isn't very helpful. You'll basically get a statement saying, here's your object. It's stored at this address in the computer's memory. But once you have this object, there are all kinds of things you can do with it. For example, if we group the data frame by the type column and then apply the sum method to the group by object, the computer returns a data frame object with 3 rows, 1 for each planet type, and 3 columns, 1 for each numerical column. Only the numerical columns are returned because the sum method only works on numerical data. The type column is an index of this data frame. This information can be interpreted as the sum of all the values in each group at these respective columns. So, for example, radii of all the gas giant planets sum to 128,143 kilometers. That information probably isn't very useful in most cases, but the total number of moons could definitely be something we want to calculate. If you want to isolate the information at particular columns, just insert the columns as a list in selector brackets following the group by statement. You can also use other methods instead of sum. For example, min, max, mean, median, count, and many others. Group by will work on multiple columns too. When we pass a list containing the type and magnetic field columns to the group by method and then apply the mean method to the result, we get a data frame that contains a row for each unique combination of planet type and magnetic field. Again, the columns contain the mean calculated values for each numerical column for each group. Group by is very useful because it helps you to better understand your data. It's also useful to organize data that you want to plot on a graph. You'll learn more about this later. Another important method to use on the group by objects is the ag method. Ag is short for aggregate. This method allows you to apply multiple calculations to groups of data. Let's start simple. What if we want to group the planets by their type and then calculate both the mean and the median values of the numeric columns for each group? We call the ag method after the group by statement. In its argument field, we enter a list of the calculations we want to apply to the data. If these calculations are existing methods of group by objects, they can just be entered as strings. We can group by multiple columns and apply multiple aggregation functions to each group. For instance, we can group the planets by type and whether or not they have a magnetic field, and then use the ag method to calculate the mean and max values of each group. And we can even define our own functions and apply them. For example, suppose we want to calculate the 90th percentile of each group. We can define a function called percentile90 that uses the quantile method on the array and returns the value at the 90th percentile. Then we can call this custom function in our aggregation. Notice that we can enter mean as a string because it's an existing method of group by objects, but we type the percentile90 function as an object because it's custom defined. Group by and aggregate are two tools that together can give deep insight to the story that your data is telling you. The types of calculations that we just viewed are daily tasks of data professionals in nearly every field. Even though we only applied them to a very tiny data set, the same exact operations would work on a data set of every planet in the galaxy, if we knew them all and if we had enough computing power to perform the aggregations. There's a lot more we can do with group by and aggregate, and as always, I encourage you to explore more on your own. But you should now have a solid understanding of how and when to apply these tools. Hello again. You've learned a lot about Pandas, that it's a powerful library that makes working with tabular data easier and more efficient, how to select and index data in a data frame, how to filter data using Boolean masks, and how to group and aggregate data to derive insights from the story it's telling. In this video, you'll learn how to add new data to existing data frames. This is a common task for data professionals, but it's not as simple as just adding two data frames together. There are important considerations to be aware of. By the end of this lesson, you'll have a good understanding of what these considerations are so you can make informed decisions about how best to add data to your project. We're going to learn about two Pandas functions, concat and merge. There's considerable overlap between the capabilities of these functions, but it's most important that you learn the basics of each because you will encounter them regularly as a data professional. We'll start with the concat function. Recall that to concatenate means to link or join together. The Pandas concat function combines data either by adding it horizontally as new columns for existing rows, or vertically as new rows for existing columns. It's also capable of handling many data-specific complexities that arise, which allows for a high degree of user control. In this video, I'll demonstrate how to use the concat function to add new rows to existing columns. But remember, there's plenty of support documentation if you'd like additional information. Pandas has a specific way to indicate which way we want the data to be concatenated. We do this by referring to axes. In fact, many Pandas and NumPy functions have an axes keyword, so you can specify whether you want to apply the function across rows or down columns. The two axes of a data frame are 0, which runs vertically over rows, and 1, which runs horizontally across columns. We'll use our basic planets dataset to demonstrate how concat works. This data has 4 planets, their radii, and the number of moons, but it's missing the data for Jupiter, Saturn, Uranus, and Neptune. Now, suppose we want to add this data, which exists as a separate data frame. Let's examine this second data set with information about Jupiter, Saturn, Uranus, and Neptune before joining them. Notice that this data is in the same format as the data in the DF1 data frame. It has the same columns for planet, radius, and moons. To combine the two data frames, we'll want to add DF2 as new rows below DF1. To concatenate the first data set with information about Mercury, Venus, Earth, and Mars with the second, which has information about Jupiter, Saturn, Uranus, and Neptune, we call PD concat and insert a list of the data frames we want to concatenate. Then, we need to include an axes keyword argument. This instructs the function to combine the data, either side by side or one on top of the other. We want our resulting data frame to have 8 rows and 3 columns, which means we want to combine the data vertically. In other words, we want to add new data by extending axis 0, the vertical axes. Perfect. The data was added as new rows. Notice that each row retains its index number from its original data frame. If you want the numbering to restart, just reset the index. We can include the drop equals true argument because otherwise a new index column will be added to the data frame, which we don't want in this case. Now the enumeration of the row indices goes from 0 to 7. The concat function is great for when you have data frames containing identically formatted data that simply needs to be combined vertically. If you want to add data horizontally, consider the merge function. The merge function is a Pandas function that joins two data frames together. It only combines data by extending along axis 1 horizontally. Let's return to the planets. Now, we have the radius and number of moons for all 8 planets, but suppose we want to add the data for the planet type, whether it has rings, its average temperature, whether it has a magnetic field, and whether it has life on it. Perhaps this data exists as a separate data frame, but it's missing Mercury and Venus, and it has some recently discovered planets from other star systems, Janssen and Tadmor. That's okay, we can still work with this. First, let's conceptualize how data joins work. For two datasets to connect, they need to share a common point of reference. In other words, both datasets must have some aspect of them that is the same in each one. These are known as keys. Keys are the shared points of reference between different data frames, what to match on. In our case, the keys are the planets. Each data frame contains planets for us to match on. Now let's consider the different ways that we can join this data. We can join it so only the keys that are in both data frames get included in the merge. This is known as an inner join. Alternatively, we can join the data so all of the keys from both data frames get included in the merge. This is known as an outer join. We can also join the data so all of the keys in the left data frame are included, even if they aren't in the right data frame. This is called a left join. Finally, we can join the data so all the keys in the right data frame are included, even if they aren't in the left data frame. This is called a right join. Let's examine how each type of join affects our planet data. First, we'll call the function and enter df3 and df4 as the left and right positional arguments, respectively. Then, we include the keyword argument on, which lets us specify what our keys to match on should be. In this case, we want to use the planet column. Now we have the how keyword argument. This is where we enter the kind of join we want. Let's try inner first. This merged the data and only kept the planets that appeared in both data frames. This means we're missing data for Mercury and Venus from the left data frame, as well as for Janssen and Tadmor from the right data frame. Now let's try an outer join. Our function call will remain the same except for the how keyword argument, which we'll set to outer. As expected, this results in a data frame that contains all the keys from both initial data frames. Notice that because Janssen and Tadmor aren't in the left data frame, they don't have information for radius and moons. So these columns get filled with NANs. Similarly, because Mercury and Venus aren't in the right data frame, they too are missing some information in the final table, which is represented by NANs. Next, we'll do a left join. Again, the function gets the same syntax except for the how argument, which is set to left. This results in a data frame that retains all the keys from the left data frame and only the keys from the right data frame that exist in the left data frame too. So Janssen and Tadmor are excluded. Finally, we'll perform a right join. As expected, the result is a data frame that has all the keys from the right data frame, but none of the keys from the left that weren't also in the right. So Mercury and Venus are excluded. Nice job. Now that you know the fundamentals, you can use these Pandas tools to do the most common kinds of data joins, which will be useful for a wide variety of data projects. And as you advance in your career, you'll discover even more about joining data and how it can get very complex. These tools will be a big help as you do. You've come a long way, and we are now ready to start using Pandas to explore your data like a true data professional. See you soon. This is the end of the fourth section of the Python course. You now have a strong foundation of Python skills that you can continue to build on throughout your future career as a data professional. In this section of the course, you learned how data professionals use data structures to store, access, and organize their data. Understanding which data structures fit your specific task is a key part of data work and will help you analyze your data with speed and efficiency. We reviewed fundamental data structures that are super useful for data professionals: lists, tuples, dictionaries, sets, and arrays. We also discussed two of the most widely used and important Python tools for advanced data analysis. The first was NumPy, which data professionals use for its computational power. You learned how NumPy can help you rapidly process large amounts of data and perform useful calculations. The second Python tool you learned about was Pandas, which is a powerful tool for analyzing tabular data. You learned how Pandas can help you perform key tasks such as filtering, grouping, and merging data. Data professionals often work with tabular data. You'll use Pandas throughout the rest of the certificate program and your future career. Coming up, you have a graded assessment. To prepare, review the reading that lists all the new terms you've learned, and feel free to revisit videos, readings, and other resources that cover key concepts. Congratulations on all your progress. Way to go.